the spoke generally it's a J bend. One side is like bent at 90 degrees, the other side is straight. And the straight side, we're gonna have a nipple that will thread it into the spoke on the rim, and that'll keep it in place.
If you cut it short, wouldn't you be cutting off that threaded part?
You could rethread that.
Yeah.
Please. We could rethread that with a cap and dye, or we could put in a custom order. I haven't honestly looked at the online website as far as custom orders, but
that'll get looked into before CDR. Any other questions? Peter?
Can you go back to the belt fixing slide for me?
We don't have a belt.
Sorry, the chain tension. I'm
No,
sorry.
you're good.
Deposition brain. So similar question to excavation. That shaft looks very thin compared to the diameter of the bolts. Are we planning on shrinking the diameter of the bolts or expanding the diameter of the shaft? Also, those bolts look incredibly long. Are we going to have to specially source them or make them ourselves? Or am I missing it and that's actually a reasonable size?
With MasterCard.
What size of bolts is it?
I think it's about 3 inches.
We have 3 bolts.
Yeah, they're 3 inches long. Because that's 2-inch box tube, and then they go about an inch down.
Okay. And then similarly, is the shaft going to be larger or smaller, or the screw size going to change?
The shaft is possible. So the question was, is screw size or bolt size going to change? The shaft is possible to change size because, as you can see, it doesn't fit in the sprocket correctly at the moment. So that size is likely to increase slightly, but the ratio will likely stay similar.
And then, are there any concerns with us tightening bolts unevenly and causing the system to go askew or bind?
The question was, is there issues with, do I have to repeat the questions? Okay. A little bit, yes, there is a concern with tightening the bolts differently and it going askew, but that is very easy to check. It's called eyes and a level. But we can check that as we tighten it, and so then as they go in, because they're rivet nutted at the top, as they go in, we can just check it as they go in.
If you don't, I'm going to keep asking questions about this if no one else has questions.
I have a quick
Yeah.
Yep.
So we switched design over other designs because of the frankly rather large force pushing upwards on the chain tensioner.
Yep.
Are we concerned about whatever the catching mechanism using both bolts in place failing and the entire tensioner getting shot out the top, the catching off?
That is now a fear of mine, but no. So we're going to use rivet nuts at the top. Those should hold. If those fail to hold, we will beef it up.
Great.
Yes.
Is there currently a plan for keeping the sprocket in place on the shaft?
Spacers. They're not in the CAD.
I would lean towards retaining rings, I think.
Okay.
I don't necessarily like the idea of the spacer being up against the bolt thread, I guess, and getting it in there seems like a pain. Also, given how it's supported, do you actually need the slots in the sides of the chain guard?
Yes, a huge concern is that when the chain goes against this and pushes, that it will push the sprocket to the side and it will kind of just fly off. Because they aren't threaded all the way through the axle, they're kind of just put in there a little bit so that it can push down. So that is a concern that we had. So that's why we have the slots on the side. So that if
When you say pushed out, like which direction do you imagine it being pushed?
Okay, so like that way. Like your chain goes like this. And so when the chain goes to move, it could pull it to one of the sides, and that is a concern.
So your concern is basically if this is the plane of the chain, the sprocket being pulled this way or that way?
Yes,
Why are the bolts not preventing that?
they should, but it's still a concern. So we put the slots in the side because of the calculated torque that we
Related
found.
question.
Yep.
The main question: if the steel bolts are failing that method, do you think the polycarb is going to stop it?
The steel bolts aren't going to be what's failing. What's going to be failing is the connection point between the bolts and the axle, which we aren't willing to change because of how they connect, where it goes against the flat part. We think that there's not enough there to hold that in place. That is why we're looking to change it.
Okay, and so, well, and then a potential idea for that is that instead of having, this method, you could have it go all the way through and just have both been tacked down each side.
We did think about that. Our concern with that method is that if it is not put in level, that makes it much harder to get it level, because then you will have one that's like slightly higher than the other with trying to get it level.
I can see that, I think I can remake it, but.
Yeah. But it was drawn on the board last night, so actually behind you.
That was all true.
All right. Any other comments?
Yeah, the chain guard is made out of polycarbonate.
Yes.
What thickness?
Undetermined.
How do you plan to make that?
So as we learned last year, we have difficulties bending things, but we were trying to bend it while it was like, for lack of better words, like cold or room temperature. So what we discovered is that when we heat it up with a heat gun, it bends much nicer. And there's a very nice medium where you don't get the bubbles, but you also get it bent. So the plan is to heat it up and then try and bend it. But we were able to successfully bend it last year with some trial and error with the heat gun. So now that we know those things, it should be much easier to manufacture.
On that note, is there a concern of losing the precision on those slots or other holes when you bend it?
Yes, there is. So that's why we're going to add some tolerancing to the slots. That's why we also looked into multiple other methods for this besides the slots before we decided on the slots, because of that manufacturing.
I'm not sure this has been looked into, but right now you're relying on slots in the polycarb. Could those slots be a separate piece that's hanging down just inside the polycarb?
They could. That adds a lot more weight,
Okay,
which is why it wasn't looked at the beginning.
fair enough.
How do you determine, how do you make calculations on how far apart those side sprockets are supposed to be?
There's no exact calculations. However, when we were looking at the sketch for where the chain would go, it didn't operate, so there's not a chain in here. But when we were looking at the sketch for this, when we were tensioning it, it was able to tension 3%, I believe you said?
Yes.
It was able to tension 3% of the total chain length. There's a lot of chain pieces on there, more than 30, so it should be able to tension it just fine with the spacing it currently has. If there's an issue with forces, we'll look at changing the spacing between them.
Do you know how far apart those bolts are?
No.
Okay.
How far apart are the bolts? Here, just over here.
Which bolts?
These two bolts. How far apart are they?
I think I set them around between half an inch and an inch. It wasn't exactly set.
Between half an inch and an inch.
Okay, because I'm wondering if it would be possible, this long bolts make me nervous. I'm wondering if it would be possible to instead have them going, well, instead have it like a clearance hole at the top and have them only go through the bottom plate.
We talked about that. The issue with that is you would then need to use Allen keys. We want to use the hex so that we can fully tighten the chain instead of trying to crank an Allen key.
Okay.
Yep.
I see on slide 48, you're planning on still using rib nut mounting gearboxes.
Yes.
The one thing I'd say with that is last year we had some concerns at competition, which we thankfully never realized, that the chain would physically interfere with rib nuts as it moves. Maybe consider removing one of the rib nuts if the chain is not centered, to then give more clearance.
That
Same
can,
thing goes for any bolts that go into the gearbox.
the riv nuts can definitely be looked at. The bolts have already been taken care of. I don't believe there's a good picture along here, but the bolts for this are going in. Yeah, so the bolts go in at the top. So there's one at each top. What we discovered last year is the bolts at the bottom that caused the master link to break because they were different length. They were too long. So the bottom location when the bolts were slightly too long caused the master link to break, for those of you who didn't know. That's why it continuously broke during competition. After we changed the chain guard one time, because the wrong type bolts were used. So we switched to only having it at the top. Because we now have the slot in there, we will likely have to add another bolt for that piece, but we'll make sure the location is where even if the wrong screw gets put in, where it's slightly too long, it won't break the master link.
I couldn't think otherwise. I've realized that I don't think the idea of needing to get the tension really tight makes any sense at all. Because you're not fighting against that tension force when you're tensioning the system, right? And you don't want to over-tension the chain, right? So you're not actually fighting any tension force except the natural tension force. So, and given that there's screws, we're not going to, like, pushing on the screw from the bottom is not going to make it go up. So that, like, the position will remain constant. So I don't think actually you'll need to really crank down on these at all. And I think doing so would probably be detrimental to the health of the chain.
Okay. We can definitely look more into
And then
that.
also, if you needed really, really high tension, we can just put an impact driver.
This is just another recommendation for success based on past performance, but when you do like this chain system, and this goes for every subteam that uses chain, you should do analysis to make sure that you have enough tension to give plus or minus one chain length. My freshman year, like 2 years ago, we had this issue on drivetrain, and we had to like slot gearbox holes because we physically couldn't get a chain link closed, or else it would feel.
We've made sure of that. All right. Nice. Power and hardware.
So, the only thing we're doing right now is the microphone over there, so if you're speaking, you can speak into the microphone, that's your comment. And that also means the permission aspect. Hello, we are the power and hardware sub-team. The general overview of what we're going to be going over for mainbot is system architecture, battery protection, which we have 2 potential designs. Team C will be going over the breakout board and our custom microcontroller project. The current sense, we have 2 designs for the mainbot, one for the battery and one for the actuators. And for box design, we have breakers, hard research, and CAD. First up, this is the general system architecture. This is roughly how the connections are going to look in the box. So of course we have battery management and then the required power meter and e-stop, and then all the components that I was told from the other sub-teams we would need to accommodate. First up is the battery protection circuit.
All right, so real quick overview of the system, or the circuit. This is really just to protect our battery when we're doing testing on the robot during manufacturing, because we sometimes leave the battery on, we leave the robot on overnight, and that has the potential to kill a very expensive battery. So we just want a very cheap circuit to be in the robot so that we don't kill another battery and waste a lot of money.
That's good. So changes from last year that we're doing. Last year we used certain TI chip that did not work as intended, or did not work as well as we intended. So we came up with some of the custom designs. We have two designs that some people are going to talk about. Other than that, other changes is going to be slightly more resilient. We're going to still use the same latching relay, which will be good. And yeah, I think we're going to hand it off now to the first group who made their design.
Okay, so for the first design, we're using a 555 timer in monostable mode. So basically what the circuit does is we have the 6 battery cells. So we filter down the 6 battery cells for the lowest voltage out of the 6. And then from that lowest voltage, we then see if that voltage is lower than our minimum threshold, which is 3 volts in this case. So basically how we do that is we convert the lowest voltage 3 volts to 1.67 volts. And if it's lower than 1.67 volts, then it releases a signal out from the monostable 555 timer. And then from there, it activates a MOSFET driver, which then activates a latch and relay, which breaks the entire circuit.
For some general concerns about the circuit would just be general board failures. So, for example, no power or a board shortage, and general part failures. So, for example, failures with the 555 timer, or relay, or NMOS, and these would essentially just entail just the circuit not working. In some cases, such as erroneous undervoltage detection, this could be a loss of vehicle function as it detects the voltage incorrectly and stops the vehicle entirely. Not to worry though, this is not that bad. All of these things are pretty easily detectable, and we can generally test the board, make sure it's verified before run that everything works fine, and the board should be good to go.
So the second design is the same function. We use the TI BQ77915 chip, and it detects whether there's each cell, whether the voltage is too low or too high, and then it cuts off the discharge fit. And then we're currently using the power NMOS, but we're probably gonna change it to a relay design because it is prone to failure.
Yeah, and then just like the previous design, very similar DFMEA. Really, whatever it's like pretty severe of just it's some degradation to vehicle performance as the robot will just shut off. But most, if not all of these, are very detectable in like during use and during the manufacturing of the board. So just essentially. Just like the previous design, it has very similar risk factor.
Okay, for the teensy, it's pretty much very similar to previous year's designs. For those of you who don't know, the teensy is basically a breakout board that integrates like different sensors and electrical components. And the base functions are mainly just to communicate with the different sensors, interface with the motor controllers, and to communicate with the computer. And in order to do all this, we're using a few different electrical components. So one of the things we're using is the MAX 3485 chip, which is going to translate the motor RS485 protocol to UART, so the microcontroller can process the signals. And then we're using a saber tooth for the 2 linear actuators, and we're planning to have LED indication like last year as well. And we're also adding a beam break sensor for deposition. So pretty much the design has been fairly similar to last year, plus or minus a few things. So not a lot of change here. And in terms of the DFMEA, since the design didn't change that much neither did the DFMEA. The main things to be concerned about are just like general loss of data, general part failure. So we just want to make sure we're soldering everything and when it comes back from manufacturing, everything's just connected properly. So yeah, I want to hand it off to Ari to talk about a fun little project we did to do.
So in addition to the current breakout board that the TNC team is working on, we're also working on developing a custom microcontroller. This will be used in future robots. And when I say future, it's because a new microprocessor would require software team to create new code to essentially make it work. So that's why I say future. So the custom microcontroller would use a Raspberry Pi RP23 microprocessor, and some of the benefits offered by this project would be a lower cost, a great a great opportunity to learn more, and it would potentially give us more. It will make the microcontroller more customizable. So the next steps in terms of this project would be to finalize the design, select footprints and our layout, actually solder the PCB and hand it off to software for it to be coded.
Okay, so the next board is the current sense board, and pretty much the goal with this board is to be able to measure current from various components of the robot, such as the battery and the linear actuators. This semester, we decided to introduce a couple of new projects. We wanted to explore two different current sensing solutions, those being using Hall effect sensors and using a shunt resistor. We were able to find various ICs to be able to facilitate these current sensing needs. So now I'm going to pass it off to Ryan to explain to explain the first board.
This is the first linear actuator board with the current sense. It's the same ADC as last year and the same Hall effect sensor, which is the ACS711, and has a 12.5 amp nominal current limit. The only things that have changed from last year is that we added jumpers to allow for more variable addressing, which just adds more flexibility in the case of a board failure. And we switched to using Wago connectors because Wago connectors it's a 2-terminal block because it gives cleaner connections than just solder.
And this one is for the battery. It has a different Hall effect sensor, which is bigger and beefier for the higher demand that current sensing for a battery would require. But other than that, it's the same as the previous board. Just having jumpers for variable addressing and also Wago connectors so we're not dripping solder on frayed wires like last year, but yeah.
So these DFMEAs are pretty similar to last year as well. Pretty much anything that could go wrong, short on the board, overheating, no power, no data out. The only new things really this year are the jumpers are new this year for addressing on the boards. Since there's 3v3 and ground on the jumpers, you have to be careful not to short that, but just don't solder it incorrectly and that won't happen. Additionally, any failure with the Wago connector will be a problem, kind of under no power as well. But again, those seem pretty reliable, should not be any issue with those.
All right, moving on to breakers. The purpose is to prevent overcurrent from damaging some of the components so nothing bad can happen. We are planning on protecting the linear actuators, drivetrain motors, software's computer, and the excavation and deposition belt motors with our breaker board. And then the battery also has a separate breaker from, it's off the breaker board, it's on its own. And so I have a connections diagram and then a size estimate diagram. So the main things to note is that you can see the layout here. The board is not too large. It has to be a bit large, but we do have two different designs in mind. So I've been receiving some conflicting info based on whether we should have a relay for the e-stop or not, if it's redundant or not. So I just decided to add both designs just to make sure everyone's thoughts were included, but I desire to receive feedback about this during PDR. And I'll move it over.
Yeah, so this is part research, mostly talking about bulkheads for now. We're gonna have pretty similar bulkheads to last year. Really the only big change is our D-sub connector is going up from 15 to 25. This is due to a new motor, and a lot of our motors are changing now to having Hall effect inside of them. So we have more wires to go through the D-sub. But yeah, it's mostly pretty similar, focusing on dust protection. So almost everything here is rated IP67. That's a standard for dust proofing. And Yeah, we're gonna have to do the D-sub, a little bit of dust proofing ourselves because it doesn't come in with dust proofing, but yeah.
Right here are a few of our preliminary designs for the actual box itself. Right now, we're working on our design for the CAD. Right now, our main priorities are planning for bulkheads and other design considerations for it. You can see we intend to have a clear panel on top like last year so that the power meter is visible at all times as per the requirements. And here are the DFMEAs for the box design and breakers. So the main problem that can come up with the breakers is tripping prematurely. But we have a wonderful breakers team this year, so I have full confidence that they were sized correctly, so that should not be an issue. And for box design, the main issue is dust protection and megalith concern. But again, as long as we choose correct bulkheads and we take precaution with dust proofing, that shouldn't be an issue either. And for the time being, for power and hardware, our next steps for the boards are to be like reviewing and PCB design, and then of course finalizing our designs for all of our projects, and then we will be able to get into ordering all of our parts. Gotcha. Now I'll be opening up to questions.
Sure. So in your system architecture, you mentioned that we're going to have a framework in the main robot. Just so you know, the main robot's going to have the Jetson, and the mini bot's going to have the waveform computer. Just as do you think it would be possible to move that aux battery to the mini bot, or do you think there's options?
I would say,
We can also talk about this during the mini bots.
yeah, I can definitely look into that. I would have to look more into the physical constraints of the minibot box design. That could also be a minibot question. But changing the actual computer in the system architecture should not be that big a deal at the moment. The TNC is well equipped to handle both of them, I believe.
For your EQ 7795 slide, I don't know what any of that means, but it says does most of, oh, I thought that said work most of the time. Okay, wait, my other question, I thought that said works most of the time for some reason. That's never happened, but I was wondering why you're switching from Waco connectors, if you're talking about in the current sense, it said you're just like switching away from those.
We are switching to Waco connectors for everything. Yes, it is standardized this year.
Okay, and then I was wondering, so are you guys looking into like compacting the box just for like weight saving purposes by any way possible on the main bot?
So I know one of the concerns this year with like new things from software has been how we're going to fit everything in the box. And so I think board size this year is going to be something that we look at. But yeah, at that point, I'm not sure box dimensions.
Yeah, because for the slide you had the CAD of it,
Mhm.
are there dimensions for that, or is it just the CAD from last year?
Yeah, so we are mostly operating off of the dimensions from last year, which is 14 by 16 by 2.3, I believe. And again, that was last year's dimensions. I have to get some confirmation from drivetrain and other mechanical sub-teams for what exactly we can put in there. But whenever they've asked me, what would you prefer to have your dimensions be, I've always told them that probably at a minimum. So that's what we're working with right now. Like I said, once they finalize their designs a little bit more and tell me exactly how much room I have, this will probably be a lot more finalized. That's why I mentioned it's a preliminary design. As for better box management, spacing wise, I think a lot of it could be saved with proper cable and wire management. So I'm putting a lot of emphasis on that this year. I intend to have a lot of plans, a lot of contingency plans for those plans to make sure that our box is as neat and organized as possible. And with that, we'll be able to maximize the amount of space we have this year, even though we have a lot more components than last year.
Was there issues with dust in the bulkheads last year, or do you guys are talking about like dust mitigation in the bulkheads? Was there an issue previously, or are you just making sure to watch out for it?
It's just an important design consideration. Like I said, as long as the bulkheads are sized correctly and rated for dust protection, this should not be an issue.
Okay, it wasn't previously an issue. Okay.
No. Alex?
On your DFMEAs, you mentioned that there was a concern with sizing breakers properly.
Yes.
Yeah. the slide number, I'm sorry. Yes, here it is. So you mentioned those, concerns. Two other extreme highest ones are breaker cycle. And then several of the components, such as most remote controllers, as well as I believe the Jets itself, have built-in overcurrent protection that will likely be more accurate than your breaker because they have access to more of their internal state than an external breaker does. Have you considered relying solely on that overcurrent protection instead of adding a second layer of defense? Especially that second layer of breaker defense that you're adding might either not do anything or fail too early and cut off performance.
So yes, I think okay, so last year we had no breakers in the box, which is, and we were solely relying on certain things like the motor controllers, having the overcurrent protection. And my belief, I think there's been some differences in communication past couple of weeks, but I think overall, we don't need too many breakers. I think we need one main breaker for the entire power system, just in case a wire comes out of a radio connector and shorts to the frame, and so that way we don't blow up the battery. But besides that, I do agree with you that we do not need breakers for every component because a lot of these things already have built-in overcurrent protection. And we can measure current and we can determine. That way we're not cutting components off too early. So I think that's going to be a change.
What battery will you guys be using this year?
The battery we are using this year, we intend to use the same battery as last year, which is 22 volts, it's 24 volts, and then I believe 400 watts, 200 watts. Yeah, 16 amp hours. Yeah, 1600 amp hours.
Are we going to reuse the exact same battery, or are we going to buy one of the same ones?
Yeah. So at the moment, if viable, I intend to at least reuse the battery for the main bot. Obviously, second semester when testing comes around, if for whatever reason we find out that too much damage has happened to it, we can look into buying a new one. But if it's viable for competition, batteries are expensive. But of course, like I said, we would have to do a little bit more work and research to make sure that it is viable.
I'd like to add on to that. Just to add on to that, I do think getting at least one new battery a year is a good idea, just because these we put them through a lot, and for competition, we want to ensure that things are good. Overall, in the grand scheme of things, they are not the most expensive thing, especially because this is a critical component of the system.
Where will that battery be mounted?
Yeah. This is another thing I would have to speak to mechanical subteams about, but last year we had it on the side in a little bin so that it's not in the box. For those that don't know, the reason we don't have it in the box is because previously, there's a lot of very sensitive components in there, and that causes a safety issue, and we'd much rather not go through and have to worry about safety issues. It's much safer if it's outside the box. With that, it is better to have it outside the box. Last year we did have a very similar design with the conveyor belt. With that, it could be in a similar spot. Again, I would have to speak with mechanical subteams to make sure that it's viable. But again, with the similar design, at this point, it would definitely, at least I prefer it to be in a similar spot where it's on the side in a bin where it's safe.
Yeah.
Yeah, definitely don't be afraid to insert a general dimension into the TLA because excavation deposition, we're gonna be designing, and then we don't want to hit a point where there's not enough room to fit a box here. So definitely make sure to have some sort of semblance of that existing in the TLA, because otherwise we're just gonna have to redesign the systems again. So just definitely next week or in the upcoming weeks, we should have that, just our box in the TLA with the battery. Because this is gonna affect weight distribution of the robot, and then there's a lot of critical design things, like P&H doesn't come last, like you guys are very critical sensitive, so we wanna design around you guys, not have you guys just design around us, you know, because you don't want your wires to be in inconvenient places, and places that don't make sense, so.
Yeah, thank you. I have been communicating, as I mentioned. The sizes I gave are what I've been communicating with the mechanical sub teams on. Ideally, I would have this as a minimum for our box, but I'll make sure to put that in, as you mentioned, the TOA and whatnot, and on. Gotcha. I'm good.
In your DFMES battery protection circuit, you had mentioned that it has a chance to shut off the robot during competition. We're not having it in the circuit during competition, correct?
No, we are not having it in the competition.
I will say one of the things I am hoping to add if I get around to designing it is a battery diagnostics board, because I believe we can add that. This does not have a relay in it, and it would simply read the cell voltages, and we can combine that to measure things. But that to just measure battery capacity over time. Overall, though, we're not going to be able to kill the robot with battery protection during competition. We'd rather kill the battery than kill the robot during the run. Yeah.
So let's get two different battery protection circuits.
Yes.
Which one are you using and when is that getting started?
I think so. Yeah. I know I've already made my decision, but we are going to make these decisions very soon. I want people to do their layouts and get these manufactured so we can test them. But I think that but one of these designs I would prefer. Overall, these designs both have viability, but we're just going to test and see.
Yeah, very similar vein.
Yeah.
You have two current sense circuits. Which one are you using them when you find deciding that?
So, in terms of current sense, I think we have some ideas over here. Same vein in terms of design and testing, though we will see here, Justin.
The idea was that I wanted to use the Hall effect sensors for the main bot and then the shunt circuit for the mini bot. That was the original motivation. Just to have two different solutions for both bots. I thought that would be an interesting thing. But I think based on the reliability of both solutions, we might end up going with one rather than the other. Either way, I wanted to be able to manufacture all the boards just to make sure that all the projects are seen through fully. But yeah, it's kind of like same answer for the battery protection, where it's we have a design in mind that we're probably going to use. But
I would be very careful about using two different designs onto robots unless there's a specific reason to, just because there's a lot more chance of something breaking.
Yes, I agree. I think overall, one of the changes we made this past year is making the address selectable, so that way we can have multiple of the same design on one robot. And so I think there is a very good possibility that we just stick with one design.
Alex?
Yeah. On the PC board, I noticed that you use 5 volts in several places. Where does that power come from?
Yeah, so the same with last year. I believe this year we're intending to power the TNC from the Jetson, and that's where the 5 volts comes from. Yes, it comes from a USB port.
Yeah. And as the USB port is currently a no connect, so that may need to be connected at some point. Otherwise, you may end up with no 5 volt power.
Yeah, where is our fence?
This can be a later discussion as well.
In previous years, we haven't connected anything to the V USB port. We just get V in directly.
I know the key is also not connected to modules, I don't
Rip.
Oops.
So maybe you guys wait.
Yeah, no, this is, I'll make those changes.
Another alternative option is to keep it like this and to power it with a separate converter. They're not very big.
I will. Can I add something? I will say, especially, I would like to do something like that, because especially if we are powering like a 5 volt servo off of something, I would rather not have that drive current from the TC board. And so I'd rather have a separate converter for that. And I saw that and I was like, oh, we should add that.
That was my next question.
Yes.
Hey, make sure
I do not want power in the servo from the TC.
Yeah. Make sure the plasma power exists somewhere.
Yeah.
Thank you.
How teenage bots be mounted to the robot?
Yeah, so right now, again, speaking with mechanical sub-teams, there are two viable designs that we've been told. The first is it's mounted the same as last year, horizontally above deposition, but it's at an angle. This would leave room for more room for excavation, because I know they wanted to expand this year. However, I've also been informed that there's a potential that that design does not work, and in that case, we would mount it on the side, on the frame of drivetrain. Those are the two leading designs right now, at least for this spot. And at this point, the first one would be preferable to us, but we can absolutely see what we can do to make the second design work.
Like the same weight, we just came off the side, we won't have to have those supports. Like, yeah, but do you guys want it higher for like wires, or like wire management, or like?
Yeah, so there are a few advantages of horizontal blocks. The first being, of course, wire management. There are some concerns with the vertical design. The first, of course, being weight allocation. If our box, which is relatively heavy, is on one side of the robot, that causes some weight concerns as for tipping over, and also,
Yes.
yeah, that's also, like I said, we can absolutely make it work. I'm just explaining why we might prefer horizontal design. As mentioned, it's definitely a viable design, and we could absolutely make it work, but I'm just explaining why we might prefer horizontal box. There's also, of course, when the box is horizontal, gravity kind of works with us, where of course we still mount our boards, but it's a lot nicer and cleaner to have them rest on a plane rather than if it's vertical, of course, if any extensions and whatnot are loose, that causes a lot more concern, especially with the robot bumping around and whatnot. So those are just a few of the reasons we might be horizontal, but again, as mentioned, vertical is absolutely viable for us.
I'd like to add something to that. Just to add on to that, in the past, we have had vertical boxes, and in the past, that has not been fun to work with.
Just like a comment on that, we do the same sort of mounting mechanism as last year. I think it needs to be adjusted. We struggled last year to manufacture them, and then it was also difficult to implement into drivetrain. Even now, it's very, you can move those supports around a lot. The whole box moves around a lot. I think we're fortunate that it works as well as it does, but we need to put more planning into it this year. So maybe after CDR or after PDR, we should start planning that process.
I absolutely agree with that. I think I've been in touch with Andrew about the supports and whatnot. It was a concern raised to him, and he did say, as chief engineer, he would make sure it was taken care of. And of course, we still intend to work with him on it, especially into CDR and whatnot.
Last comment for me. This is a comment moving forward as well. I don't know if you've done any consideration for the ceiling of the top of the P&H box, but I also believe that should probably be thought of more so than it was last year as well. Of course, we had that break right before competition, and we needed to get help to fix that. So whatever mechanism we go to seal that, we just need to consider that.
Yeah, absolutely. So that actually is something I've been considering. I didn't say anything because it's not finalized yet, but I'll go a little bit into it. So last year we did have an unfortunate incident with the lid, which was opened like on a hinge, and that was not fun to deal with, especially because it was pretty late in the game. This year, it might. I would, again, not finalized. I would definitely have to look into it, but I'm considering other designs. Maybe, of course, just better protection for the hinge, because I believe regolith getting into the hinge was a part of the reason that it's not. And then also this year, other mechanisms could include something like rather than being on a hinge, it could just be taken off without a hinge. Of course, it would still be secured on from the lid like it was last year, where there would be clamps to make sure that it would stay on and there's still dust protection and whatnot. That could be an option. That way there's no hinge. And also working on the robot ease of access is a little bit easier with that, because last year we kind of had to take the hinge up to excavation to work on it while it was still on the robot, which was kind of annoying to deal with. That could solve that problem as well. Of course, some designs are security. If it's not physically hinged to the box, there's worries that it gets up and slide around, I'd have to look into that a little bit more, and things like that. And also, it might be a little bit less secure dust protection, but again, it's something I'm very much looking into. I appreciate you bringing it to.
I'd like to add. I think this is also something we need to look at, like we get these with acrylic hinge and stuff from Protocase, and this is something we need to look at with Protocase and see.
They're more CDR concerns.
Yes, exactly. Is that what can we get from Protocase that can allow us to do these things? I do think past we've had no hinges where we can just take the acrylic top off and switch to a hinge, but we can always go back. I think last year we broke the acrylic top just from somebody leaning on top of it, and that wasn't too fun. So again, there's more considerations for CDR.
We have time for one more question.
Okay, one more question. If not, that's fine too.
Just as a general note, whoever is doing good EVOPs can come talk to me because I can help you out with the sheet metal tools and solid works and stuff.
Thank you, Peter.
Sweet.
Sounds good. Thank you all.
This will be our last topic before lunch.
All right, so for software, our system architecture is pretty similar to what we had at PDR, at SDR. We're gonna have depth cameras and LiDAR that are gonna be giving us our point cloud images. We're gonna use that to get our position, use that to get our path, and then follow that path using controllers that we're gonna talk about in a minute. And then we're gonna send that to firmware and get sensor data back from that. And we'll also have manual control as usual for teleop. Sensors on the main robot, we're gonna have 2 depth cameras on the main robot, which is front and back. Similar to last year, we're gonna have the front one mounted onto excavation. As of right now, we're thinking mounting it onto the top of excavation that moves up and down and using linear actuators for position. And then having the back camera on the PNH box as last year. Additionally, we'll have situational awareness cameras as per normal and a beam brake sensor, which will help us detect when deposition is full instead of using the load cells that we had last year. Litigation.
So one thing we've changed this year, I guess, is that we're implementing like a disincentivizing approaching obstacles or getting near them basically by implemented as like exponential decay, which is built into the ROS2 library for cost in their cost map. And this is just an image of implementing our D-star navigation with like a basic turning cost. So we try to go as straight as possible. And then there's like currently 2 approaches. Is that one is we set a hard boundary of our robot radius to ensure we can't get stuck between rocks if we're turning. And then the other one is to set a lower boundary for our radius and just kind of we're basing on the assumption that there's always going to be a path between obstacles, and so we won't have to turn between them. Yeah.
So what we're trying to look into is switching our global path planning software. Currently, we're running on D-Star, which generates paths with small turns that we have to correct, and it's not always optimal planning as seen by the prior slide. Other algorithms that we've found may be more efficient for path generation, such as A-Star. Based off of that, we have Theta-Star and S-Theta-Star, which are planning on minimizing the length of paths and minimizing the amount of turns that these paths have to make, respectively.
So some of the main benefits of Theta-Star over other algorithms is that it allows us to traverse at any angle. Most algorithms are based on a grid, which kind of limits you to that grid. And Theta-Star helps alleviate that, and then S-Theta-Star just analyzes turning. We've also migrated a lot of our libraries to Nav2, which means that we can easily swap out these planning algorithms and even control algorithms, which just gives us a lot more flexibility.
All right, so another aspect here is the perception of the robot. And what we've mapped out right here is the full pipeline of utilizing the image cameras to detect rocks and craters on the field. So first off, we start with the ROS bags from previous years. And what ROS bags are is they're basically a collection of data of all of the robot's information during runtime, including motor sensors, whatever each camera sees, which is what we're interested in, and other sorts of information. So the first step is going to be a Python extractor, which extracts the video files that we're interested in from each of the video cameras, and that's going to give us some video files that we then extract into frames. We'll put these frames through our model, not our model, but we've found a model online that we've tuned or that we've made sure works for our implementation, and that's just going to label all the rocks and craters from the images, and it's also going to mask them out for more specificity. And then that's going to go through an auto-labeling process to figure out what's what, and then we can use that data at the end of the day to train one of our own models to work on the robot in real time. So we can use the masks in complement with the depth sensors to actually figure out where are these rocks and craters on the ground.
And here's an example of what the training data would look like. So we're utilizing this model called Grounding Dino and SAM. What that means is the Dino part can take in a text prompt. So for example, we can just type in rocks, feed it this frame from one of the previous year's competitions, and it can both find these rocks and use SAM, which means the segment anything model, to draw these boundaries around them. And you can see the percentages at the top, which is just like how sure it is. So ones that are closer, it's a lot sure. It knows 70% that the pink one is a rock versus ones farther out. And we use this labeled data to then train a model that can run in real time on the actual robot.
And another one of our projects was RTAB map tuning. So RTAB map is a CPU-based SLAM system for localization and mapping. And what we did was we refined RTAB map's SLAM parameters to reduce drift and improve map stability. And we did this by tuning specific settings like feature detection thresholds, loop closure sensitivity, and memory management.
Yeah, so another issue we had last year was that the Jetson, the computer we're using, it was pretty much maxed out, and that's just processing images at 240p. So the issue was that the CPU was running at 100% basically, and the GPU was not being utilized. So since we moved to ROS 2, we can use these packages called Isaac ROS that were developed by NVIDIA. And these will basically optimize ROS for our hardware and allow for GPU utilization and higher resolution image processing.
So Isaac ROS provides a lot of different packages. Some of them include Able Tag Detection, Point Cloud Creation, Visual SLAM, YOLO V8. So currently we've implemented the code for Able Tag Detection and Point Cloud Creation. So we're going to test that out soon on the Jetson and hopefully see higher resolution on the RealSense cameras. And in turn, we'll be able to get more accurate obstacle detection.
So part of this, we've switched from ROS 1 to ROS 2. ROS stands for Robot Operating System. It means we can use modern libraries like Isaac, and also just in general, our code will run faster. Pretty much everything at this point has been moved over, and the robot should be able to run, or is running, on ROS 2.
All right, DFMEAs. So in our failure analysis, we kind of found that the most severe failure mode is that robots are unable to detect obstacles, KSC second run. So something that we're that's kind of why we've been putting such a focus on perception. And so a few things that we're doing in this regard are making sure that our sensors have a greater field of vision, making sure that we have better analysis schemes so we can actually determine where the obstacles are with a high degree of confidence, and also make sure that we have the ability to jump in at any time from this greater FOV and be able to operate with more confidence autonomously, because perception forms the baseline of our entire autonomy stack. Yeah, and I think that's about all we had. Does anybody have any questions?
Yes.
So I know that between UCF and KSC, the simulants are extremely different colors. One of them is almost white, and with salt and pepper white. The other one is this gray. And the rocks are also different colors. Can it handle that without, like, basically, if you're going to put it, train on KSC data and put it to UCF, you're going to say there's no obstacles anywhere, I'm fine, and then drive straight to a rock or a field. Or is that going to be an issue?
So this is one part of the pipeline. We do understand that there are situations, because it's gray on gray, where it's going to be unable to detect certain rocks, like the first UCF rock, right? However, that's why we're having different sensor modalities. Like we're going to have these depth cameras as well as LiDAR data. And regardless of like what the visual sensor sees, the LiDAR data will show some kind of jump there. And especially because we can trust LiDAR data more because it's time of flight, we will be able to determine that with a greater degree of certainty from that point cloud data and kind of merge the two inputs together and be like, okay, so visual didn't see a thing here. However, our more accurate 3D LiDAR data is detecting a pretty severe obstacle here. Therefore, we're pretty confident that there might be a rock here.
If you're going off, if you say that LiDAR is more accurate and we trust LiDAR more, and we trust it over visual data says you're all clear, and LiDAR says, yeah, there's an obstacle here. What's the point of visual data at all if you trust LiDAR?
So the issue was in UCF, there was a very flat rock that we could not, using the systems that we had, our depth information basically said that it was a pretty much flat field. But we could visually tell that there was a rock using the cameras. Therefore, these algorithms will be able to detect that. And we have a variety of we have a lot of data from the past like 3 or 4 years that we can use to train this data. And we'll make sure that there is a variety of different data being inputted into it. So it's not just UCF or KSC. But inevitably, we are going to be using all the different algorithms that we have to combine together to make it the most accurate. And ideally, we'll find any combination of rocks. Like some will be able to detect rocks in certain ways, and others will be able to do it with other different types of rocks.
Also, something that I do want to add on, the kind of trusting LiDAR more, that's kind of a case-by-case example. However, there are going to be situations where visual will be more reliable than LiDAR. For example, in one of our practice runs, I think, we had a situation where we got stuck in the same spot and kind of dug ourselves a trench, and then saw the entire world as an obstacle. So having kind of an idea of the fact that there are no visual rocks available anywhere in sight, we can kind of be able to estimate that that's not actually an obstacle. And just kind of
I'm still not sure you're glad to combine them because earlier you said, hey, the LiDAR says it's an obstacle, we're going to treat it like an obstacle. But now you're saying, hey, the LiDAR says it's an obstacle, but the visual says there's not, so we're not going to treat it like an obstacle. And we can talk about more details later. But I'm still concerned with which sources you can trust and when.
Sure. Peter.
For the new planning algorithm, or the potential planning of switching to theta star or S theta star. So it's my understanding that D star we've been using primarily because it was better at pre-planning the path when it sees a new obstacle. Is that a concern with theta star that it will be less performant in that scenario? Or is that something we need to try to mitigate, or is that not a concern?
Yes, that is a slight concern, but also D-Star is running incredibly fast right now. Because it's running on C++, it can run multiple times faster than we need it to. So we are essentially, we can afford to lose some of that to go to a more strict, like a more representative algorithm. And there are different things that we're looking at to improve the thing that aren't necessarily D-Star specific, including A-Star and other algorithms that we're looking at. Sophia.
On slide 79, for your cost map, what's the units for the hard boundaries?
This one.
That's meters.
Yeah, so the idea would be that we would have a hard boundary that we could not, there's no situation in which we want to go through a gap that is less than the minimum width of our, the width of our robot, really. Like, last year, I'm not sure if this is the exact
It was
same.
half a meter last year.
Half a
0.5.
meter.
Last year was half.
Last year was half a meter. This hard boundary is.
It's like considering like if you have your width is 0.75, your length is 1, and then like that distance right there. So like if you're turning and you like stick 2 corners, you get stuck in that way.
Okay, so you base off the current dimension.
Yeah.
Yeah, this is based off the dimensions of the robots. Alex.
you mentioned you're going to have two depth cameras, one going forward, one going backward.
Yes.
Not mentioning situational awareness cameras. I understand we might use the green ones, but it's like having ones in part of the areas inside deposition.
Yes, they are mentioned, and they're not placed, yes. But there will be one foot facing into deposition similar to last year, and we will be using the arena cameras most likely unless we determine significant bandwidth improvements, which we are probably not going to. Alex.
Question from the Slido, from Josh. Many localization control algorithms using modeling systems motion taking common state update and a controller's plan. Do you have a good model?
No. It is very hard to model the way that the robot moves in the regolith. It matters, like, the frictional forces are different moving forwards versus sideways, and it can definitely be hard to model. There's a lot of slip in the system. So we have not found that using a direct, like, wheel odometry-based system is particularly useful to us. We found pretty good results using visual odometry, and the LiDAR that we're also getting will also have its own localization system as well, and then we'll use April tags that we have in the starting zone as well to localize to the world frame. Dr. Marshall?
Beam splitters at deposition, are you going to know what height the deposition has?
So the idea with that would be that it would be placed in a spot that when deposition is full, it would then break that beam. The exact spot isn't determined yet because we haven't yet gone through that, but yeah, it would be one spot across. That would be the idea.
Is there any advantage to having more data or showing how quickly it will fill up? That's what the load cell will provide, right? You know how it is increasing, right? With beam splitter, you don't know.
Yeah. The issues with load cells last year was that they would not provide very consistent data. It would very heavily depend, like, if we're moving at all, it'll move the forces around, and it was very noisy data, so we weren't quite able to get anything useful out of them. We'll definitely, I believe with the beam break, just knowing that we're full or not would be enough. And we can also fuse that with just like having some idea of how much time it normally takes to fill up, and being like, if we're within some reasonable margin, that seems pretty good. All right. If there's no other questions, I think we're done.
Thank you, software. We will break for lunch now. Plan to be back here at 1:30, where we will begin with the mini bots. At 1:30. Thank you, everyone.
I'm just updating the slides. I updated them because software, or not software, KV says there's slides outside of it, and then they import them all in.
Yes.
They did have slide numbers.
It's like a live stream.
Okay.
All right, it worked. Maybe go to the old one and now in that one that was. All right. Can you edit in Studio and delete it?
Yeah, I was only gonna figure this long.
Thank you.
Go out again and then probably.
Is that the right one? Maybe 2 minutes.
Or actually, just delete forever.
Yeah.
For a while. And then just watch it work. The original stream back up.
Let me make sure everything worked out. All right. It still doesn't. I'm like standing right in front of this thing, and like you don't see me, my friend.
Oh, wake up!
How long is this delay?
I don't know.
It's like 5 seconds.
Let me go grab my stuff.
Yeah, go for it. Maybe it's this button. That's what that does. I don't know what you do. I found out what the button does, but I don't really know how to interpret it. It does change the camera.
Oh.
It now tracks me. I don't know if it tracks multiple people though.
I think it will try its best.
If you like stand there, I don't really know what it's doing. It sees you. It's like consistently a 1, I think though. Now it sees me. Maybe it's like speaker.
Yeah, maybe speaker, or it could just be like eye contact with it. Because like I turned around. So, I don't know.
It's now on you. I push the button again. I'm a human. Look at me. All right, this is a test of E5.
Did you refresh the presentation?
I think so.
Yeah. Because we added a slide. Here.
No, I didn't see this one day, but, I didn't see this one day, but I did, watch it.
It's not here.
So you can change. I know I've never heard it say these words. Oh, no, Josh. Who's Josh? Oh, that one. Is that Josh? And what is that? Yeah, that is. Peter. This is Josh over here, I think. That's been. Oh. Yeah. Is that you guys are Josh? That's this Josh? Yeah, that's Josh. Okay, cool. Yeah.
He's a smart.
I really hate the waiting time.
Yeah,
just
I was holding on as keep it XXX. Yeah. I definitely don't use it for sure. I think it's actually not Is there a mic or something here, or we just talk I've never seen this happen before.
All right. Welcome back. Test. Welcome back. We're gonna get started now. So I apologize for the change in rooms, but this will allow us to go as long as we need to get through this longer discussion regarding the mini-bot. So if this is your first time here for the afternoon, please scan the attendance QR code. I don't see any cameras, so we'll move on. Slido link is a different Slido than the main bot. So if you would like to submit questions via the Slido, please scan this QR code instead. Okay. So welcome back. I hope you had a nice lunch, and we're going to begin with the mini-bot high-level overview. Please welcome our Chief Engineer, Andrew. Chief Engineer.
All right, so as Anju said, we're going to start the second half of the high-level overview of the mini-bot. So the overall mini-bot system, on the right side, you can see two different angles of the mini-bot as it currently is. It's kind of a little cuboid, it's kind of cute. Right now, its dimensions are 41.4 centimeters in length, 67.9 centimeters in width, and 53.7 centimeters in height, with a current mass of 22.29 kilograms. You may notice that the P&H box on the mini-bot is the exact same as the one that's on the main bot currently. That will be changing. We do have current plans to kind of shrink that box a little bit, so we can actually deposit into the mini-bot, as well as just better organize and fit all the components. So as part of this high-level overview, we kind of want to give like an overview of what the two robot system idea is for those of you that don't know about it. So in previous years, the competition has been very focused in such a way that whenever you start your run, you're in the starting zone, you have to traverse quite a distance through obstacles until you reach the excavation zone. You'll mine a little bit, and then you'll just essentially back up into the deposition zone, because it's kind of just right by the excavation zone. This year, the competition has been changed so that the excavation zone is pretty much right by the starting zone. And then you have to traverse from the excavation zone through obstacles to get to the deposition zone. So with the allowance of having a multi-robot system, and this change in what the field looks like, we believe that we can kind of gain the greater number of points through a two-robot system. So the goal of that two-robot system is the main bot will be mining most of the time from the start, while the mini bot is continuously traveling between the excavation and deposition zones, continuously getting that material mined by the main bot, taking over deposition zone and dumping it, and just doing that over and over. You can see in that bottom right, kind of just a little graph of what that process kind of looks like. That'll obviously be more fleshed out in the actual competition run. And that bottom left is kind of what that arena is going to look like for this year's competition. So with that, there's again that question QR code, and then we're going to go ahead and start with deposition. I do believe also that between different sub-teams, we will not be doing a Q&A to the very end. Is that right, Brayden? Or are we doing it? Okay, so never mind. So we're still going to do Q&A after each sub-team.
All right. For deposition, mini deposition, it is quite very similar, if almost identical in terms of a lot of the mechanics of the main deposition. So we have world dimensions of 14.8 by 20.5 and a height of 12.54. The regolith size, it is different. So 14 by 17, still the same height of 8. It comes to 31 liters-ish if we fill to the brim again, which, yeah. Same motor, similar, very similar deposition speed, as well as a weight of 7.13 kilograms. And yeah, all of the mechanisms from the form cell, the sprocket, the door, the belt itself, it's all very similar to what you've already seen.
So this is a DFMEA for the transfer only. Because the two systems are so similar, most of the rest of the DFMEA from the main bot applies to the mini bot. So this line only focuses on the transfer. So there's 3 potential failures: overfill of the mini bot, which is not likely since we are not like filling the mini bot or the main bot all the way normally. Over?
Yeah, fully over.
We're not gonna fill it way over. And then there's a chance that the belt could hit the robot. So like the belt of the main bot hits the mini bot. This is a sizing issue mainly, right? And then regular tying on the mini bot. So when deposition from the main bot goes onto the mini bot, there's a chance that it could be piling too high and we could lose like some regular pattern.
So the priorities moving forward is, again, similar to the main robot, which is just implementing feedback from today's discussion. Next way, just manufacturing the belt and the desk way. This is considering the flaps we mentioned before as well. Dust protection, same thing with.
Hold a little further away.
Okay. Dust protection, just the brushes, and ensuring the sides of the belts don't allow regular to see through. Fasteners, same thing as last robot. Still need to add fasteners in the cab model so we can determine which ones we need to get. And then after that, we can plan the manufacturing steps moving forward.
Yes, that concludes system overview for the mini bot deposition. As mentioned, mechanically, it is almost identical to the main bot. So if there are any questions, yes.
So you mentioned one of the concerns was the mini bots, regular spilling out. Can you go to the system?
Yes.
Thank you. Do you know approximately how high above the conveyor belt the main bot will be deposited?
I believe the, above the conveyor belt, I want to say it's 2 or 3 inches above.
But we were looking into changing the angle to make it so we can get further
Okay,
up.
yeah, because the thing I was thinking with that giant U-shape is the taller you can make that wall.
We were also considering maybe having another, we were thinking about last night, maybe implementing a mechanism where that back wall actually like pivots down to be more of like a ramp. And then that could have sort of some like coverings or like fabric to sort of prevent it from filling on the sides. Then that could be sort of like a ramp that lowers down, we deposit it, and then it like fills back up to sort of top it up. That's what we were thinking about. But yes, you know, you're correct that sort of the most suspicious point of this is the big old U at the front. And so we're thinking of ways to try to mitigate that. Yes.
You mentioned that the belt hitting the robot, the main bot belt hitting the mini bot would be a concern. Is the belt the furthest like protruding part of the robot? Or could we make it so is this like?
It is
for the main.
For the main. Well, I believe the aluminum corner would actually be the furthest protruding part.
Yeah.
Can we make it so it isn't? So let me know for it.
So Ankur, on that note, I believe actually, think about it, the corner of the aluminum plate would be the furthest protruding part. So that might be what actually impacts the polycarbonate instead. So that would ease some wear concern perhaps. And if that isn't the case, then we could very easily change that to be the case. Yes.
Are there any concerns that the regulars wouldn't fall, like they wouldn't be able to get close enough, the rows wouldn't be able to get close enough together to perform the transit successfully?
No.
Great.
I mean, that's something that sort of we have to look at more, but not particularly, I don't think. I mean, just looking at this right here, seems like they can get pretty close. And especially once we actually get a more accurate sizing of the power and hardware boxes from the mini bot and the main bot, then we can plan that out more.
It's also helpful that the main is not as wide as minis, so main can have that bit of buffer room to just come in.
Yeah, right. So the mini bot deposition is wider than the main deposition. So the main deposition can actually sort of, we can design such that the main deposition actually fully enters into the space of mini bot. Which would completely ease those concerns for sure.
Yeah, I was just concerned about depositing it into the cavity.
Of course. Anything else? Are there any questions online that we're not missing right now? Yes.
Are you guys considering using the tools like Ansys Rocky to like model how well these two conveyors actually interface when it comes to positive resonance? Because
We haven't looked into using finite element models. Particularly to model the transfer. We could try to look into that and see how that, I haven't really used Ansys Rocky, but I can try to mess around with it. So that's certainly an avenue that we could pursue to evaluate our design better. Yes.
Is there like a reason for, I guess, the sidewalls on that like little like the plate that's actually the cutout slot?
Like these ones here?
Yeah, like, because, you know, is that versus, I guess, I don't know, I'm just trying to think, like, is there a way to like optimize that, like angle the whole entire plate a little bit, or, I don't.
Maybe. That's sort of the idea. The problem, if we angle the whole plate out, then that means that the whole system can't really start within starting bounds, right? Because then we can't get as close. So that's sort of the genesis of the idea of maybe having this front plate actuated in some way to swing forward and sort of become a funnel to accept material from the main bot.
I'm just thinking like those sidewalls have like.
These ones?
There'll be like a smaller margin of error for lining it up. You know what I mean? I don't know if it's on purpose, but you know, like if it's a little bit off center and those weren't there, it's still fine.
Maybe. And that's something.
Not on purpose.
Yeah, I mean, yeah, maybe. You know, it's very. Right now there is clearance between, like, if you had the deposition fully embedded, I believe there is clearance there.
Even just making it a little bit wider, but then again, I don't know if that would benefit us or bite us in the butt, just trying to hack recommend.
Yes, Dr. Marshall.
I'm not sure if this is the same question as Alex, but with the main bot, you can kind of use the conveyor belt to kind of move the regolith from kind of towards the excavation side, towards like I guess the back door, right? To kind of distribute the regolith, right? That could be a strategy. In this case, if I'm right, you're depositing the regolith into this mini bot where the conveyor belt is at a 90-degree, like you're depositing to the side, so you don't have, so your conveyor belt's going the other way, so you don't have that option of like distributing.
So I think if I understand, your concern is essentially since the mini bot conveyor is wider, we can't use the conveyor motion to get regolith to the sides as well and fill it up as well. Yeah. That's definitely a concern. We're sort of imagining and hoping that just by sort of piling it up against this wall, it will sort of flow to the sides and fill, and sort of the volume will introduce the fluidic state, make it fill up. The gate wall, right? So regolith will enter through the U, and then the conveyor belt will move it towards the gate wall, right, over here. And so, yes, it goes this way. Yes, the conveyor motion is going sort of along the shorter dimension of this. Yes.
Have you identified whether you can get a belt of those dimensions?
So we cannot get a 17-inch belt. We can get an 18-inch belt for MasterCard, and so that's what we were talking about in terms of the next steps of trying to figure out the best way to cut an inch off of that belt. Whether or not that the current plan is probably a jig and a bandsaw. But that's one of the avenues that we need to pursue in this. Or maybe the 18-inch belt is slightly unideal because I believe it has sort of a low friction surface on the bottom, which would make it harder to tension. So we might even have to buy a 24-inch belt that's more frictitious on the bottom, and then sort of cut that. Actually, it would be not half.
Could we reuse? No.
So we'd probably have to cut that belt, or yeah.
It might be easier to cut a wider belt than cut 1 inch off a smaller belt.
Maybe. I don't know. We'll see. You're saying why?
Why I say yes?
Yeah.
Oh.
You and Emily. Why?
Yeah, have you ever tried to cut like any sort of non-rigid material and you're trying to cut a small sliver off versus trying to cut a larger? It just forms easier and it's a lot easier to like.
Right, that's what the bandsaw is for.
No, it's like. It's easier to have like, I don't know.
I think we do.
I think I do understand what you're saying, and I've definitely experienced that. I don't know that I'm too concerned with that, because 1 inch is I think still a pretty good amount of material, right? Like if we were trying to cut like a 1/4 inch off this, I'd definitely be concerned. But like 1 inch is a fair amount of material, and the conveyor belt isn't that. Huh?
It's like pretty thick.
It's like fairly thick. It's about like 1/4 inch or like 0.1 inches thick. So.
I'm just misremembering how durable the conveyor belt was. Just cutting tiny amounts off of something that's not sturdy is a pain.
So this is something that actually we can test because we do have extra material from the conveyor belt last year. So we can test this and see how bad it is. And this conversation might not even be relevant because we're probably just going to buy the wide belt anyway.
Where are you sourcing your belt?
Big MasterCard.
Have you looked anywhere else?
Yes, it's really conveyor belt options from other places are very, very limited. Alex, you probably.
I can speak to this. I have looked. The answer for other options is old industrial surplus. It looks like it was last in the 1930s. Or do you want to pay 10 grand for like a ludicrous amount of it? And we don't want either of those.
Yeah.
And if Alex can't find it, no one can. Yes.
Do you have any other ideas with the gate? Because I kind of have some concerns with. Is that like a regular size servo?
It's listed as like a 35 kilogram servo. It provides 3.5 newton meters of torque.
And then are you mounting the door straight to the spine of the servo, or is there some sort of gear train to give it some sort of like a better place of failure? Because once you break the spine of the servo, My idea actually was replace the whole servo or just the symbol of the servo.
I don't know that there's, so right now, to answer your first question, right now it is directly mounted to sort of the arm of the servo, so the spine. I don't know that there's a huge concern. Again, we sort of don't know what the forces are going to look like acting against this door, but considering the pure weight of the door, the servo is wildly oversized for the task. Some kind of gear train is we have to be careful with, right? Because given the limited range of motion of the servo, any sort of gear reduction we do to get a higher torque means that now we can't rotate it as far, right? So we have to be, we probably if we wanted to, we could get probably a 3-to-1 reduction before it fails. So I think the servo has a 270-degree range of motion. So we could look into something like that, but it seems sort of overkill for the design. I don't know if there's a huge concern we have about right now, but we definitely are going to be trying to do more analysis to feel more comfortable in saying that we don't think it's going to be a problem. Okay. Yes.
We have a question from Slido about wheel sinkage being an issue between main and minibot deposition clearance.
Yeah, it's definitely possible and has not been concerned yet. And that has not been considered. So that's definitely a thing to look for, and probably an argument for getting more elevation on the main bot. Yeah, it's hard. It's hard to say how much of a concern that's going to be until we can actually get some estimate of how these wheels are going to perform in the environment. But certainly last year's wheels had a big problem with taking us into the ground. So that's certainly a concern.
Would that be something software could help with, about, like knowing how deep we might be?
That's a little bit hard to estimate. Something that we can do is like just move away from our meetup zone and then turn to do our excavation cycles to prevent that a little bit. But it's kind of hard for us to estimate like how deep we see.
Yeah.
All right. I think that's everything. So thank you. Thank you. And now Dragon will be presenting on their mini bot.
Yeah, that wheel's actually good.
So overview for drivetrain, we're still living well within the dimensions, a little heavier than expected, but that is due to a lot of things. This is also on the lower end because we haven't added bolts yet, but there is no chain that goes in this, so it shouldn't get too much larger. The expected speed for this is about 3 feet per second from the high end, and then we have about 3 inches in clearance. That measurement was taken while the chain was broken, so it is slightly off, so it's about 3 inches in clearance.
Okay, so the frame setup is pretty similar to mainbot with the same internal box tube connectors. Yeah, it's pretty much the same. The main thing here is the gearboxes are going to be embedded within the frame, so you can see that side rather than being another 2x2 aluminum box tube. It's our gearbox stock size, and so the gearbox is just embedded within there. It's pretty similar to our gearbox from last year, the 1-to-1 internal gearbox ratio. Motor 51, gearbox assembly, 36% motor power. We can see the stats, yes. And yeah, pretty straightforward.
As you've noticed before, we have changed up drive system. Rather than being wheels as with the main, we decided to go for a tread system. So our current tread assembly involves 3 wheels, with the main on the top being the driver, which is, it's 2 sprockets on a 12 shaft, which is connected to the gearbox. It's about 2/8 diameter overall and just about 3/7 thick. Then we have 2 idlers partially keeping the shape, just to keep it running. The idea is that they'll both be 3D printed PLA and will spin freely on stagnant shafts while the shaft is spinning. They're both about 3 inches thick. The one on the farthest right is purely stagnant and for shape, while the other one is part of our tensioning system.
For the tensioning system, it'll be on the left idler gear. We'll have a bolt that is screwed in to the actual shaft, which is stationary, and attached to another part on the frame. And around that bolt will be a spring that can that'll basically push the shaft against the tread. And that shaft will be able to slide back and forth a little bit in the frame to allow it to tension.
As we said, that we're going with treads this time, so here's like a CAD of the treads. It is 0.91 in width, 2.95 inches in length, and 0.87 height. We will be using 332 pinholes, and probably the 332nd inch stainless steel TIG welding rods. That's how they can connect to each other. And they're going to be printed in PLA, and they're based, instead of using the chain to help it turn, it's based off the number 50 chain. So
DFMEA, it's basically the same as for the main bot. However, the main difference being wheels versus treads. Treads are our main concern when it comes to potential issues. However, we're taking like every precaution we can, really monitoring our materials and stuff like that to mitigate as many issues as possible.
Priorities moving forward, implementing feedback here, adding dust tolerances, the gearbox frames are just open, adding the rest of the nuts and bolts, and then testing the treads for making sure they assemble properly and the strength of them as well. Yep.
For the 332nd stainless steel pins on the treads, has there been any analysis about whether or not those might shear under the limits expected?
PLA will shear first.
Has there been any analysis that might happen?
Yes.
Do we think it's gonna happen?
It could. We've been working on it. We've increased like the size. Hold on. The size here. Okay. The size here around the hole has been increased to try and prevent those from shearing. Also, this is a tight fit versus a clearance fit, so that should help as well. Yeah.
Why are we going with treads at all?
If we go with wheels, if you remember the size, that's 14 inches, which means the wheels will be roughly 6 inches in diameter, assuming you get, an inch for tolerances and issues. 6-inch diameter wheels are going to sink very well. They will do an amazing job at sinking. They will not do a great job at going forward and staying on top of regolith. So we decided to go with treads because treads can also support more weight, and then they're wide enough so we can still get enough surface area on the regolith. Yeah.
Regarding regarding treads, so your pins, so pins will over time be relatively turning in the PLA on the clearance fit side.
Yes.
Are you concerned about that slowly wearing through the PLA and turning your nice round hole into a nice long slot?
Do you say clearance or which side?
Either one, to be honest.
Yeah. For the tight fit side, that's not a huge concern because it's tight fit, so that shouldn't happen. For the clearance side, there is some concern there. However, as we assemble these with like the right size, it is still fairly close. But we were looking into like bores. Yeah, Peter.
Have we considered trying to use a different material?
Other than PLA?
Other than PLA.
We've looked into other 3D printing materials. PLA still seems one to work best for what we want.
In what way?
It's cheaper, it has similar, okay, so PET G is the other one we looked at, and then PLA. PET G has a higher, like, strength than PLA. However, when PET G deforms, it basically just shatters, whereas PLA, when it deforms, it's more like a creep. And so if we have an issue with the tread in the middle of the thing, we can check the treads after each match to see, oh, this one deformed, we should replace this, versus PET G, which will just break in the middle. That was a concern, that's why we did switch to PET G. If you have other experiences with the materials or something like that, please talk to me after about it, but we could totally spend 2 hours discussing 3D printed filaments, so. Sophia, sorry.
So can you go to the, just like overview pad photo? I've seen teams cut weight-saving holes out of the like triangular cover for the treads before, and they almost create, I've seen teams, they'll have weight-saving holes and then they'll have, like polycarbs, they can see inside of it if there's like regolith buildup too. Because regolith gets in there, like they would hit it with a hammer, and so much regolith would be coming out of these treads. So it might be interesting, you can also maybe save some weight, but you can also see what's going on inside there if they have a lot of regolith buildup. Kind of building on what Alex was saying about the rods going through the treads, there's gonna be like regolith's gonna get in those holes that aren't tight fit, and that's gonna cause extra friction and rubbing against the PLA, so that's just something, you know, to think about, like you probably wanna really clear it out after every run, because that's just gonna be like it's gonna sand down the holes even more once it gets in there with the rod. I was wondering how much weight will be the fasteners will add to, because there's a lot of fasteners in these treads. How much more weight is that gonna add to the treads?
So for the treads,
Because it's like stainless steel and it's a lot of them.
Yeah.
Them all together. So it's gonna be a lot heavier now.
I'm trying to do very quick mental math.
Yeah.
I can do math later,
I
but
mean, you don't have to have like an exact number, but it's like gonna be pretty heavy, right? Once
Yeah.
all those fasteners are in there. So I would say even looking into, I know we've talked about weight saving holes in the box too, but there's not a whole lot going on like dynamically with this. I do think maybe cutting holes in the box tubes might be worth a shot in this system.
for the large 2x4 box tubes, definitely, we have talked about it, it didn't get done. But we looked at the weight saving holes with the polycarb in like the tread plates, that did not occur to us, thank you. And then the pin weights, that, I can get an estimate for that later.
Yeah, it could literally just be like, you're like, this is how much one segment weighs.
Yeah. If we can just figure out how much 3 inches of a rod weighs and then multiply it by like 100.
Yeah.
Kind of building off the polycard, you probably could even go without the polycard, because if regolith is getting in there anyway, just having the holes would make it easier for that regolith to get out of that. Then
it would fill when we turn.
Would you be worried about like the sprockets and stuff over inside?
Yeah, I guess, didn't realize that it would be, the treads would be buried that far down.
No, it's a concern though that you'll get regolith above and beneath the treads, so putting like holes through it probably isn't something that we'll do unless they're like higher up on it and like just like a full hole. There's gonna be like 3 standoffs attaching this, so if we wanted to take the plate off to shake out the tread, that wouldn't be too difficult.
Okay. Then I had a main question about the tensioner for the chain.
Yes.
It looks like that is a bulk of the tensioning being done by the spring? Is like it actually kept in tension by the spring, or is it physically stopped?
So this picture is a little difficult to see it. Probably should have done a closer up one. There is a block that mounts on to both sides of the plates, and then there is a bolt that goes through and basically pushes against the axle of that like idler. Very similar to how deposition does with the conveyor belt. And then the spring pushes that away. So then the bolt can like bring it like closer while the spring pushes it away so that it stays at the right distance.
I would be very concerned about that kind of design in this system, just because it's going to be under a lot of impact loads potentially, which sounds like you could then push that back catcher inwards on the spring, unless I'm misunderstanding.
It can, and I would just, then it would just go back because it has the spring. Also,
Yes,
this
but
is,
then during that time, it would potentially skip teeth and could destroy your 3D printed parts.
that's true, but the teeth sit so far into the chain that I don't think that is a major issue.
That's just something I would be very concerned, especially if you also have regolith in there, because regolith will get in there. That could then build up and slowly push that tensioner inwards, which then potentially could create a different failure mode.
Do you think there's like a way to mitigate that?
Just not having the spring tension, you have to make it rigidly tensioned.
We can look into that. This tension system is the same one that Iowa uses.
Fair enough, if that's demonstrated use,
They have mentioned issues with their spring before.
They have, so we can look into that. But yeah. Okay. You had your hand raised.
Yes, so now I've got a couple of questions. So staying on the topic of the tensioner, is the axle of the idler also constrained like to the plates?
Yeah, there's a slot in the plate.
Okay, I understand. And then for the 3D printed, like each tread or each link, I guess, have you guys thought of integrating like a second material to take most of the load from the pins? Like I know a lot of teams,
Yes.
like even outside of Lunabotics, will use like 3D printed parts for like the bulk of it, and then aluminum plates or anything like that. So why is that the one that we're using only 3D printed?
We have thought of that, and we're still working on that. The issue is finding one that is this size and also long enough for what we need. We physically could not find pins that were this long and also that tiny diameter that work for McMaster-Carr and $4 each. So, but we are looking into that. That is difficult to find, and the concern with that is that causes a larger hole to be needed for this part, which means there's less 3D printer around it, so it could break more easily. So there are their own concerns with increasing that hole to put like an aluminum, like hollow shaft through there, for an example, to then put it through. So that you wouldn't have that regolith issue and you wouldn't have as much against the PLA, but it also would have less PLA.
I didn't mean like a hollow tube, I mean like a hollow plate, or not a hollow plate, but like a aluminum plate or polycarbonate plate. So like wherever the 3D print is thickest, put a plate that's got the same profile as that, and it would essentially just be a section of the 3D print that's stronger, and that would take most of the load. But you still have the shape of the 3D print, so it still does the function.
I'm not sure I understand the advantages to that. If you have an example, I'd be happy to look at it later. I'm not sure I can visualize this either.
It's kind of similar to what we did for excavation, how we had the metal pulleys and then a 3D printed pulley. They all share the same profile, but some of them are metal and some of them are plastic.
Sorry, someone's bottle just rolled down half the aisle. Okay, I think I understand what you're saying. I still quite don't though, so show me later. Yeah, okay, got it.
With regards to the pins, I know on Amazon, I know that pins are, if you're trying to find a specific length pin, that would be difficult. But if instead you broaden your range to shafts, so you can get a long, like, a 2mm shaft stock, which is pretty dang close to 332. And then you could also potentially have 2mm bushings that are inserted into the free-flowing side, or the spit side.
Bushings are what I meant earlier by saying like the hollow shaft. I just forgot the word bushing. We can look into that. We did a lot of research trying to find ones that were long enough. Like if you look up the pins that are the right diameter, you just can't find any that are longer than 1.5 inches. We can look for shafts. Yeah.
I looked for this. Searching up 330 seconds rod gives you the first 2 pages are all welding rods.
I just looked on the McMaster card, you can buy a 6-foot long, 332nd, 4140 rod for $18 off McMaster.
Can you send me the link for that? Wonderful.
Also, a question, I guess, for these people. What was the advantage of that over welding wire? Because welding wire is dirt cheap. Relatively.
I think just probably material design, I don't think there is a meaningful difference, probably. Like, floating wire probably is not nearly as hard as a dedicated shaft.
That's fair.
That, yeah.
All right. Yep.
I had a gearbox question.
Yep.
Yes, so this gearbox is significantly farther away from the edges than the main robot gearbox.
Yes.
Just because it has a boxy body. Do you anticipate assembly difficulties?
Yes. Yes, and we're currently working on that as well. Yeah, so one thing to note is this entire motor section here, it fits through that hole, so you can just take it out and put it in. So the issue is this piece now, which we're looking at putting, again, with like the weight saving holes, is we can also just do like an access hole somewhere nearby, so that it's easier to assemble there as well. So we're looking at both that.
I'd also like to add the spacers. I think we're reducing our problem like we did last year because that was much more successful. We learned a lot last year in assembling that gearbox, and we were literally discussing over lunch various ways that we can use what we learned last year to make this easier. It definitely can be done, and with what we learned last year, I think we can figure out a way beforehand that we can do it pretty efficiently so that the actual assembly should go well if we just plan well enough beforehand.
John?
So I have a question about the treads. I'm concerned about Reglet getting stuck in the drive sprocket. I think where the drive sprocket interacts with the tread and holes, I'm concerned about Reglet getting inside that gap. And then the drive sprocket just basically skipping a bunch of teeth. So those treads are full of Reglet. Is that a concern or?
That has already come up. I think it was just phrased a little much differently. Yes, that is a concern. Yes, we're working out ways around it. One of the ways is getting it to fit together properly. And then also not having holes in the plate will help because the plate is also very close to the treads, so that'll help prevent you from getting it. Yep.
On topic, we have a question from the online saying, on the note of holes within the system tread, I assume mentioned the importance of having channels in the channels in like the plates to allow the dust to flow out from the tracks. And we can get you.
So that was me. That was just saying. I remember hearing. I forgot to tell my name. My bad. That was me saying. I remember hearing something about like holes and being termed the dust flowing up. But there's an importance of making sure that there are places for dust to exit out from the tracks. Because dust is going to get into the system no matter what, as a function of we're taking it and we're moving around, right? So you need to make sure that there's going to be some way for the dust to then also get out and not just be stuck internally forever.
Yeah, we can look at that more. The concern of why we didn't do it is because we also didn't want to like invite dust in. Like if you think of a boat, when you have a plug at the end and you get a wave that splashes into your boat, if you're standing in the water, it'll slowly fill with water until you get to the line, right? But if you are going fast, it empties. So there needs to be like a good in between. We also need to find the threads so that it's not filling like the hole and causing regolith to get in, but it's also allowing it to exit. That was our concern, which is why we don't have them in this design. It seems like there's a lot of concern about it. We can look more into that.
Like the places it's gonna get in is when it's going over these arches, right? Because that's when the treads open up. And that's when whatever regolith that's sitting on them is gonna fall through. So you can place your channels anywhere near like the driver, the idlers, because that's when the treads are gonna open up more versus when they're in straight formation, it's probably not gonna leak through as much.
That's a really good observation. Yeah. Yeah, we'll look more into this. If you have more really good observations like that, please let us know, but we can move on for now. Any other questions? Kyle?
I guess technically you could also go hard the opposite direction where you know that regolith is going to be in there anyway, make it so that there are gaps in the chain that will let it out as soon as it moves into the open air.
The concern with this is, as you can see, there are gaps here. We don't want these gaps to fill with regolith as well. So if we make the gaps too large, it'll just fill. If we make them too small, then they don't turn. So there's a very fine in between.
I'm saying in the actual part, have basically holes in your tread. That
I seem to remember last year a very, very long debate about having holes in wheels for drainage purposes for the exact same reason, and it was determined that that would not be a good idea. I still believe that to be true. Even though it was my design at the time, I still believe that to be true, that it's not a good idea. So I will stand by that with this as well. I think having treads in the frame or plates would be good, but not in the treads. We're already having enough issues with sizing constraints and the different pieces in the treads. Having holes is not a good idea. Yes.
I just had a question on the general design of it. So the most tank treads that I've seen, they have a line of wheels or a skid plate going across the bottom.
Yes.
Where it actually contacts with the field. Why did you guys choose to not have something like that?
So the plate part of it was because it's tension, we don't need the plate to be pushing it down. Also, if we have a plate in there and then we go over a rock or any hard object, we've just broken the treads. Versus if we go over a rock here, the tensioner will move and then we can kind of just go over and continue on our way. What was the second part?
Having a couple of wheels going across the bottom so that it's not gonna sag or droop as it goes over stuff and be more.
Yeah, okay. So typically those designs are used for suspension tread designs. What those will do is they'll all each have a spring on them, very similar to this, they'll just be rotated and then they're all along. You'll see those a lot in Land Rovers or land treads. That is not the type of material that we are driving on, it will not be helpful for us. So we do not include those. We could have included them and then have them rigid, however, that doesn't give us any major benefit. Maybe having one in the middle would, but looking at the spacing, it probably wouldn't help that much. Also, weight concerns.
Those from Eric Reiner's says the tracks look like a D11, love it.
All right, we'll take that. Yeah, they look like Iowa. Yeah.
This kind of also applies to the main bot. I have a lot of concerns with this frame connection piece.
Yeah.
I feel like it's gonna be a tolerance nightmare. The box suits that we have are not exactly 2x2. And then manufacturing that, you have to align 2 axes. Really, it's a lot more than that. Because you have one plate, you have 5 faces that you have to align several bolts on.
Yeah.
I just feel like that's gonna be really hard to get consistent.
Tolerancing for this will be a challenge, however, the way that it's assembled should make it easier. The piece, so this piece slides into the frame and then you put 1, 2, 3, 4 in, and then you put the frame on the outside. So that should make it a lot easier for it. Tolerancing is still an issue with that. But it shouldn't be as bad as if you tried to do it all at once. I do understand your concerns with tolerancing stack up.
I just don't see it. I think once you tighten one of those bolts, then everything else is already essentially constrained because it can't rotate either because it's inside the box.
Well, you wouldn't fully tighten just one bolt. You put all in and then tighten them equally.
Everything is threaded, right? The block itself is.
Yes.
So there's no real tolerance there either. I think it's just gonna be really tight.
The tolerances can be found in the frame pieces because those will be clearance fit.
Oh, okay.
Yeah. Sorry, that was a little clear?
I think that makes it better. I still think it's gonna be a challenge, but.
I'm not disagreeing with the fact that it'll be a challenge, I just think it should be okay because these are clearance fit.
I will also say that those are definitely makeable. It's just going to be very annoying because at least right now you need access to at least 3 sides, potentially 5 sides.
Yes.
There's going to be a lot of take it out, put it in, 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 which is where your tolerance stack up really shows up.
Yeah.
So I would be very careful about that. If there's a way to make it so you don't need to machine five out of the 6 times in the queue, that would help.
Do you need that many bolts?
Just kind of through the mirror design thing.
This is more than last year, right?
No, last year had, okay. The T bracket last year had 8, I believe. Or, yeah, no, it was 10. And then, it was 8 or 10. And then the, L corner one had 6.
Yeah.
Yeah.
It's just like that many points of connection on one piece can cause a lot of stress and the fasteners can work or that one piece is gonna work.
As we saw from last year's where it bent, yes.
Yeah, I don't think that's still very possible with this system, but you guys can try it.
I think you can get away with taking away a lot of those bolts.
Yeah, it's I don't see a reason to have that many.
There's not much stress on this element, like that cross frame anyway, right?
I think all it's being mounted to is deposition.
Yeah.
So that's just sitting on top.
So you could, it's mainly, you wouldn't want to get rid of these 4. You could maybe bring it down to 3 if you had to.
Those 4 are not hard with anything.
You could bring C2 maybe. We can look into that more. Tolerance stack up is a concern. We've been careful with tolerance stack with other things, so. Yes.
Could you move, instead of having 1 bolt on each side, just have 2 sides with 2 bolts on that side? So you don't have to go, you have the same number of bolts total, and you don't have to get to 2 sides.
The concern was mainly spacing out the bolts. So if we did that, we would just do 1 bolt on 2 sides. Probably not 2 bolts. Or,
It's pretty far apart.
yeah. We'll take you. You can make it decently sized apart, but. Yeah, okay. Any other questions?
Also kind of note from last year with the gearboxes, if those shafts do have defined lengths, keyways.
These are gonna get changed to 1 keyway with retaining rings on each end. We couldn't find the CAD file.
Okay, so it's keyed all the way throughout and then a retaining ring on each side.
Yep.
Do you know where you're gonna get that?
Yeah.
I will say it's not the easiest to find.
We can get it from McMaster-Carr and then make our own retaining ring slots.
Okay, because I know Misumi, for some reason, doesn't have that option.
They don't have the
They
9mm shaft anymore. They have 9, 13, 17, and 21.
Do you not enter a custom shaft size?
What?
Do you not enter a custom shaft size?
No, it gives you those, when I looked this morning, it gave those 4 shaft sizes.
Alright, it's just wait.
Okay, when she looked an hour ago, it was also just this 4.
Yeah.
So it was not an I can't read thing, it was, they have those 4. But McMaster-Carr does have more that are keyed fully through, we just have to make our own retaining ring slot in them.
It's a 9mm shaft?
11,
11mm?
12, it's 12, it says 12.
Wow, so it does.
All right,
Neither of us agreed, it's great,
are there any other questions for drivetrain?
yes.
Thank you.
Thank you, drivetrain.
Yep.
Oh, yeah.
Okay, we can go ahead and get started. Again, we are Power Hardware. So the general overview of what we're going to be going over is system architecture, general considerations, actual hardware, and we have a separate current sense board for this robot. So the system architecture looks like this. As you can see, there's a lot less components than the main bot. This is because there's a lot less to consider. Biggest being lack of linear actuators that gives us a lot of space and of course frees up the amount that we need to use. So the general considerations is 2 boxes and 2 batteries. I did look into the battery. It would more than likely be the same one we're using for the main bot, which I double checked, 22.2 volts, 355 watt hours, 16 amp hours, and I believe weighs about 4.5 pounds if I read the data sheet correctly. And of course that all brings up cost, weight, and design considerations. We need to factor in not only the battery weight and size, but we also need to factor in the weight of another box and whatnot on the main bot. There's also general labor of manufacturing double boards and 2 boxes. That brings up concerns of time constraints that we're going to have to plan for ahead of time, which we're already planning on. Fortunately though, it is very similar architecture to last year's box. So we have a good amount of blueprints and resources we can use for it. And most boards would be duplicates or very similar to how they are already designed, which is also good for us in our workload this semester.
Yeah, this is mostly repeating a lot of the things that Victor just said, but basically, when it comes to stuff like the bulkheads, connections, and wiring, it's pretty much going to be exactly the same as last year's box. When it comes to stuff like that, once again, they're going to be duplicates of all of the boards. They're going to require some small changes. They're not going to be the exact same. And the breaker design that we talked about in the main bot overview will remain mostly unchanged. Once again, most of the boards will be pretty similar.
All right, current sense. So this was originally designed as a current sense board for the linear actuators on the mini bot, which is now understanding that those are not a thing anymore. So it's now an alternate design for the main bot, actually, involving shunt resistor, as we kind of mentioned during the main bot presentation. This is probably not going to end up on the bot. Talking about a little bit, since we're going to try to stick to one design, it's probably going to end up being Hall effect, since that's what we know and already trust from last year and previous current sense boards. Though this one, again, just some ICs here that integrate a shunt resistor into a differential amplifier to output a voltage to the same ADC as we've used previously on other current sense boards to detect the current. Again, we would be able to use this with the main bot if necessary. If there was something wrong with the Hall effect board, but not currently expecting that at the moment.
I mean, yeah, you basically just said, okay. Yeah, so this is a current schematic. It's the same ADC as last year. It's the INA-254 for shunt resistor-based current sensing. It has a 75 amp nominal current limit, and it outputs 40 millivolts per amp of current output from the battery. Just like in the other boards, it uses Wago connectors for cleaner connections and uses jumpers for variable addressing in the case of board failure.
Yeah, so as mentioned, a good portion of our boards are going to be super similar to what we described in detail with main bot, so we're not to go over that again. So that is all for us now. Are we fielding questions now?
Yeah, so you mentioned that we would be using the same battery on both robots, and that weight was a concern because each of them you said weighs about 4 pounds.
4.5 roughly.
So we're spending just under 10 pounds of our total robot budget mass on just batteries. Has there been a consideration to downsize the batteries? Because I know that we, especially if we robot will use less power, because the mini bot won't have adaptive activation system, so it won't use less power that it'll use.
Yeah. So as Ryan mentioned, recently the actuators taking off the mini bot, that was part of the reason I was pretty firm on keeping the amp hours for between the two. But with that removed, I can definitely look into potentially downsizing. Again, there's a lot less components now to worry about, especially without an excavation system, as you mentioned, things like that. Potentially, I will say there is a very good reason we've sized the battery for the main bot as it is. So I would have to personally go through and do the math to make sure that we would be able to downsize the battery.
I may be wrong, but I believe that the very good reason is because we kept rounding up at several different points. I think it was like original was like 9 amp hours, and then we couldn't get a 9, so we got a 10, and then when we ordered the battery, the 10 was out of stock, so we got the 13. But the 13 was, but the 16 was cheaper than the 13 for whatever reason, so we effectively, significantly increased the battery capacity. I would double check math. I strongly suspect that we can drop down at least to 10 amp hours and possibly to like 7 or 8, which would save us a huge amount of weight.
Yeah, as I mentioned, I'm open to definitely looking, but I will say I will have to 100% do the math and make sure that it works out. But it is something I do plan on looking into, especially now that things like motors are becoming more finalized. Now we have an accurate, more accurate idea of how much power we are going to be using. So that's going to help a lot with that.
Are you guys planning on like doing a whole separate proto case for this, or are you planning on us manufacturing just something super light and simple?
Like for the box?
Yeah, like are we gonna do like a full-on proto case and try to source it from them too? Like, or is that like overkill for such a small teenage kind of system?
That is the plan right now. I haven't heard of any alternatives because, I mean, the main thing with, again, proto case is they've provided us with pretty reliable boxes and dust protection. That's a big thing with it. The mini bot is going to be, of course, running around, so it really needs to be dust protected, especially with regolith being dumped onto it constantly. We really want to make sure that it's secure from that, make sure that it doesn't damage our electronics. If there potentially was a cheaper alternative, I would be willing to at least look into it. But right now, for simplicity and for, I guess, just previous knowledge sake, a proto case is the way I'm leaning right now. That's what I intend.
Yeah, not for like cost reasons, just for like, we should, like, I'm just wondering how small it can go.
Yeah. It would be a different design, so it might be smaller proto case, but.
Regarding batteries, just note that we only have 2 batteries at the moment. We do have some smaller batteries. Don't know how well they're going, if they work or not. But we would probably need to buy batteries regardless of whether we're using the same batteries or buying new batteries. So just.
Yeah, absolutely. That's what I mentioned. Like, it's a cost consideration for batteries for mini bot along with an extra box and whatnot. We've discussed there are some ways where we could potentially curb those costs a little bit, but it's still something we're looking into. It was something I mentioned that it is a design consideration that we're looking into. Someone else put their hand.
Yeah, so this was something that was considered taking advantage of a lot of the dead space that exists between the frame rails of drivetrain. What happened that made us move away from that and now move to another box?
Chassis box.
If that's what we were calling it.
When it was with the motors.
Like on top of the skid plate almost, between the motors and the frame.
Yeah, with the motors, okay. So Emily did a lot of hard work, and I gave her my list of components I need to put in the bot. And she actually did size and put that box with the motors, and it was physically impossible for me to all fit. So that, along with a bunch of logistical things like while the motors were in the box, wiring to those specifically might be easier, but getting the wires and whatnot all around out from the bottom would be really tricky. There's also access that I was worried about. And in general, putting it on the bottom does make me a bit nervous because, again, some electronics in there are pretty fragile, especially we have like a computer in there and we have some exposed chips in there. It is not the ideal situation to put on the bottom where it constantly be potentially getting hit by rocks or again, regolith concern is also a big deal because it's right next to the wheels that are making up regolith, and unless it's like ultra super dust protected, I would worry about regolith getting into the box and damaging our electronics. Anyways.
Do you have like a ballpark estimate of the dimensions of an e-box for the mini robot, or is that still need to be figured out?
Yeah, so again, with things changing, things are just now getting finalized for the mini bot. I kind of held out on that just a little bit. But based on this, you can see again, as I mentioned, there's a lot less parts that we're gonna have to consider with it. So with that, it more than likely could be smaller than the main box. Yeah.
And on that note, do you have the motor controller needed for the deposition motor in there?
Oh, yeah. The reason it's just motors here is because I believe the drivetrain motors have built-in motor controllers. I was kind of considering them, but for specifically deposition, there would be a motor controller attached. That would be attached in a similar way the previous system architecture was attached. This was more me tracking drivetrain motors because those were finalized a bit earlier than you guys'.
What do you mean? What do you mean by that?
Oh, yeah, but, so, I would need to do the official math now that things have been finalized, but more than likely it would be a bit smaller than, but again, I can't promise anything. If it was the same size as Mainbot, that would probably be good enough, but if we need it to be smaller, I would have to look into it, but that's probably possible.
I'm like not an electronics person by any means. What would it look like if you had like a 2-story PNH box? Is that like chaos? Like would that cause like so many issues? Like if you literally just have like a second layer?
So, things that concern me right off the bat, I would need more time to think about it, but wiring concerns might be brought up. Also accessibility, I guess that seems a bit redundant to be able to have to take off 2 layers every time we need to access the box.
Yeah, I just know we're just like, the box is the way it is because everything's like laying flat. And obviously like certain components should be on like the bottom floor, so to speak, but like, I don't know, I'm just like, what is like double decker bus, like the PH box, but.
I think wiring and assembly and accessibility issues are the first things that come to mind. I think there are probably a lot more issues. I would have to think about it a little bit more and give you a more detailed answer later, but off the top of my head, frankly, it probably would just not be very fun for us to manufacture and have to wire and work with.
Yeah.
Where's the battery in this robot?
Yeah, as mentioned like last time, should not go in the box because that brings up a safety concern. So not going to be in the box. Again, ideally because the deposition system is so similar to the main bot, whatever we do for the main bot is more than likely going to be transferred to this bot. Again, that's also a me and mechanical sub-team's decision to make, so I can't speak definitively. But again, ideally it would be kind of in a box on the side of the robot, like it was last year, because that did work for us last year. I personally, at least for current hardware, didn't pose that many issues. So if we're going with what works, that is, but of course, as mentioned, I would have to work with mechanical sub-teams to make sure that would work for them as well.
I think based on the current GLA, that's not possible.
Better, maybe will probably go inside the frame.
Inside the frame, put on the box. Okay, yeah, we can work it out, but that's probably, yeah, like I mentioned, that's me and mechanical sub-teams talking for a while, making sure both of us are cool with where it is. But just not in the box, I would tell you that much.
Kind of on that vein, how is PNH bot?
Yeah, again, with this very similar deposition system, we did touch on this earlier, I believe. So it would be a little bit smaller than shown in the schematics before, but it would be mounted very similar to mainbot where it's on top of deposition at the moment, at least. As mentioned, if that doesn't work, there is the vertical option, I believe, with this design as well, that we could look into. But again, with the schematics from earlier, that's what it was looking like. Just again, potentially a little bit smaller so that depositing regular into the mini bot would be easier.
Thank you.
Anything else?
We have a question from the slide out asking whether it would be reasonable to make the boxes the same between the 2 bots.
Okay. Do they mean like the same like dimension wise and bulkheads wise, or do they mean the same like part?
They asked the question anonymously, I don't know.
I'll just answer both real quick then, I guess. So dimension wise, again, that's a more mechanical and key decision. As mentioned, it would be a lot better if the mini bot box was smaller because it's easier to deposit regolith with that. So that would be again more mechanical consideration, but that's part of the reason we probably wouldn't have the same dimensions. There's also the fact that I know at least drivetrain uses different motors between the two. I think they can use the same bulkheads, but I have to double check on that. So Maybe bulkhead configurations could remain the same. I would have to do a bit more research again, now that things have actually been finalized. As for hardware, as mentioned, the mini bot just does not use as many components as the main bot. The main bot has actuators, and the mini bot does not. So that means we don't need motor controllers for actuators, we don't need bulkheads for actuators, we don't need like all these extra connections, like from power to the actuators. There's a decent amount of hardware that actuators use that are just flat out not in use in the mini bot. So it's out of the question for them to use the same exact hardware. But as for things like the teensy, like that's going to be pretty similar between the two boxes, and like things like the battery protection circuit, that's going to be very similar between the two boxes as well. So there is like specific boards and hardware that won't change between the two, but the configuration of the boxes will more than likely change.
Adding on to that, you may have went over this, mentioned this yet, but the ManyBot is intended to be a little more software heavy, which software we'll get into. So that will require some different, not list different, it's more just core components in the main bot each will require, so.
Yeah, it is more software heavy, so there's a little bit less on us as well. I agree.
Any other questions for power and hardware?
Thank you, guys.
All right, so for software, first we're gonna start with kind of our behavioral overview. This is very similar to what we talked about in the TIM, but just to kind of go over it again. So in the first cycle, when everything starts, the deposition robot is first gonna go out of the excavation zone, and it's gonna identify that meetup location. And then after it's reached its position, its meetup location, then it signals that to the excavator robot so that the excavator can move to the meetup location without running into the minibot. After this happens, then the excavation robot is going to start its cycles in kind of like an expanding semicircle to make sure that we keep getting material on each cycle. And the minibot will continuously run cycles back and forth between the meetup location and the deposition zone. And on interactions, they're going to have kind of a really tightly coupled handshake kind of maneuver where one has to signal the other when it's ready to deposit material into each other, or when say the minibot is ready to accept. So it's not a situation where we're kind of like having to keep watching back and forth between messages and having to deal with latency during those crucial points in time. So yeah, this just continues over the computation cycle.
In terms of sensors that we're going to be using for the minibot, we're going to have at least one depth camera on there. That will be a real sense camera, but we're going to use for localization and mapping. We're also going to have a Unitree L2 3D LiDAR that's going to be on the front of the robot. That's also going to be used for localization and mapping, and that should give us more accurate information about the obstacles. We're also going to have some situational awareness cameras, potentially, depending on what actually fits in there and what we have available. And they're going to be 3D printed mounts to the B&H box as per normal. In terms of homing in that behavior, when we're getting the two robots to align to each other, there's going to be an able tag on the back of the main robot on the deposition door, and then there's going to be a camera on the P&H box on the mini rod that's going to be facing backwards, like across the robot, so that it has enough of an FOV to be able to see that able tag even when it gets pretty close, and it'll just align using the able tag display. That's all we have. Any questions?
Can you go back a slide? Sorry.
Yes. Carol.
Realize I may have missed this in the first half of the presentation, or for like the main robot part of the presentation. How do you do the initial localization of the robot?
Yes, we're going to be using able tags that are in the starting zone. We'll have, similar to last year, we'll have 1 or 2 able tags on the corners in the starting zone.
Doesn't that require the robot to spin in order, because isn't orientation randomized?
Yes, so the rules are slightly different this year in that you're allowed to start your autonomy after the match starts, as long as you're within the starting zone and you can still gain full autonomy. So the idea would be that we would take manual control, align, make sure we have correct localization for the able tags, and then start our autonomy cycles. And that would still be eligible for full autonomy, assuming we don't leave the starting zone in that beginning. Yes.
Is there a reason why in this video you have here, the large bot waits at that long black line instead of meeting the smaller bot halfway?
So the idea would be that it would always go to the same spot, and that would be much easier for us to have set up in that we don't have to have the mini bot try to figure out where the main bot is. We can just say, as long as at some point they both know where that spot is relative to where they are, that's all that matters. If we're trying to do stuff where the main bot's moving away or the mini bot's moving around, we are concerned that we would not have an accurate idea of where they are relative to each other. The other problem that may occur is that we're not exactly sure how the autonomy rules are going to work with two robots, and that they might require us that the mini bot has to be within the excavation zone to be able to count as a traversal. So that is another thing that we have to ask Q&A about and see if we can get clarification on. But that might be another concern. Yeah, that's why we have it at that spot.
Nick.
Real quick, can you remind us on whether, if even, the two bots communicate with each other into the control center and what they're talking to each other about?
Yes, so in the behavior script, you can see that these diagonals things are basically they're waiting for a communication from the other robot, and then the trapezoids are sending a communication. So at the beginning, the deposition robot's going to go, and it's going to send a communication once it has that meetup location, and the main bot's going to wait for that. And only once it gets that communication, then it'll go to that location. And then during the link up procedure, once the main bot has it's completely full and back at that location, it's going to send a message to the deposition bot, which will then, as soon as it gets back, it'll be ready to align to the robot, and then again it'll send a communication back to the main bot telling it to, hey, you can now deposit into the mini bot. And then the mini bot will, once the main bot's empty, the main bot will then communicate back to the mini bot saying, you're good, and the mini bot will leave. Yes.
Sophia.
Sorry, and then they will not, there's no necessary communication to mission control. As same as last year, we're gonna, if they're after we started, if we lose communications, we should still be able to run, even though there's no communication back to mission control. Mission control is just gonna be monitoring what's happening, making sure that things don't go wrong, but not require communication. So yeah.
If the mini bot somehow gets stuck somewhere, would we have to stop autonomy? There's no way of getting autonomy to then give the main robot priority, and then it just starts acting as a lone agent. We would just have to take manual.
So yes, as of right now, we would probably have to take manual. If we have the time, we can explore that. But for the first priority is just take manual and then try to get it out of the way so that we can do that. But we are also looking into partial autonomy states, especially with just to figure out, okay, if in these failure states, what can we still do autonomously? Because excavation, deposition, traversal are all separate this year. So we can still get some points. It's just we're still kind of figuring out as to what degree we can get them.
Yeah, and not this is if for some reason the main bot fails, what autonomy can we get with the mini bot? Would it be can we get some sort of traversal?
Could likely get traversal.
And then just can we push rocks this year?
You would not be allowed to bulldoze, okay. So you would have to lift it up, which is the thing that we can do with just the mini bot. Okay, Peter?
This is from a while ago, but this is a question from Eric Reiner. What is the estimated time to align, dock, and transfer regularly from the main bot to mini?
Yes. So similar to last year, we had a similar process in our deposition process where we were aligning to a berm able tag and moving towards it and then depositing in the berm zone. And we found that we had pretty good accuracy of that, and it took about 15 seconds, I'd say, to do that. So we were estimating that we would have about the same amount of time to do this, maybe a little bit more because of the nature of it being maybe having to be a bit more precise than last year, but we had pretty good accuracy last year as well.
Yes. And then on a related note, are there any concerns about the mini bot experiencing odometry drift over time and no longer meeting up with the main bot?
Yeah, so there might be a little bit of drift over time. However, we've corrected the issue that we had during our practice run last year, where we had a significant odom drift, and our robot kind of just had a completely incorrect frame of reference of where it was. That is corrected now, so we should have a lot better performance. It is still we still do need to test a little bit to see to what degree we're doing, but we do have methods for correcting this. For example, the excavation robot has an able tag. So if, say, for example, like we're more confident somehow in the excavation robot's position, or say that the excavation robot can see the starting able tag really well. In those cases, then we can also just do like a transform chain where the excavation robot sees the able tag and then we can see the able tag from there. But there's multiple ways that we can fuse in data for better odometry.
And when we're depositing between the robots, we're going to be aligning to the able tag on the excavation robot, not where it thinks it is based on odometry.
And then on a related note, is the plan to keep the main bot sort of like get the main bot in position, so keep that static, and then have the main bot fully aligned to that? And so in that case, is there a concern that if the main bot has experienced some angular drift and is not like say perfectly 90 degrees to wall or something, it's possible the main bot would have to maybe drive further towards or be in a position and make it more difficult for the main bot to actually get to a valid position for the transfer?
I'd say that is definitely possible. I'm not entirely certain. I think that based off of what we are seeing in terms of odometry drift over time, it's not very likely based off of, and we can, since the excavation robot will be in closer to the starting zone, it'll likely have a better chance of being able to see those able tags in the starting zone. And we could potentially add in like a bigger able tag in the starting zone that will be able to see much easier, something like that to make it more accurate. Dr. Mitchell.
Would there be any reason to have like a sensor to measure the regolith in the mini-bot that it's actually been deposited in?
I don't believe that there would be I don't think that would be necessary, because we're not gonna be like, oh, we're not full, and we're gonna wait for the excavation robot to do another cycle or anything. At that point, like, we're gonna take whatever was transferred, if it's 80%, if it's whatever, and we're gonna just do that, because that's like what we have at that point. I think that it would make more sense to just do it than wait for more.
Also, are you planning on having a situational awareness camera pointed into the bucket or something?
Yeah, it's possible. We'll have to look at what we have in stock and what we need, but yeah, what our visual look like there.
Yes, Sophia.
If the mini bot like comes back early and the main bot's excavating, is it priority for it to like finish excavation, even if it's like somewhat full, or will it like stop operation? Like, what does it look like when they're like waiting on each other? Like, would it get lost, or would it just like stop at that meetup point?
Yeah, so right now, as it's written, we are gonna wait, the mini-bot's gonna wait until the excavation cycle is complete before before it'll come back, and it's not gonna tell it to end early. I think that will depend on what our final numbers look like in terms of testing. Like, if we're able to do this traversal very quickly, then we might want to add in a thing saying that we're gonna tell it to end early, or just like normally just reduce the amount of time that it's gonna be excavating for, and maybe speed up the trenching speed or something like that to be able to get the material faster.
Are you planning meeting up like right at the border that separates, or is it just like, are you ever worried that they're gonna meet up in a place that technically it shouldn't be like the like, I don't know.
So the location of the meetup point is going to be kind of determined by the mini-bot. The mini-bot's going to find the best available route outside the excavation zone, depending on the rules, depending on what we get from the Q&A, whether the excavation robot has to be completely outside the excavation zone for that handoff, or whether they can meet up at the border. It will kind of depend on that, but the fact that the mini-bot will be able to find a route outside of that, we will be able to figure out like where that point lies from that mini-bot's path.
Yeah, like there must be a path between excavation and deposition, because that is how the competition works. Yeah. So then we're gonna pick a point along that path that is, depending on the rules, gonna be.
Is it right that it's like the excavation should be much faster than the mini-bot's path, like to deposition?
That is what the numbers look like at the moment in terms of previous
given that, and then you're gonna have new linear actuators, right?
Yes.
Okay, and you think you're gonna have better sensing capabilities with those?
Yes.
Okay. Are you going to try to, slow down, I mean, is there any reason to slow down excavation? Either save battery power or to improve the terrain, disturbance?
Sure. Yeah, I think that's definitely something we can look at. Maybe not going all the way down into the ground. Maybe only go skimming it a little bit and maybe go deeper per run or something. Or so you don't have to go as far away from the starting location, the meetup location. Definitely something that we can test when we actually get the numbers, because right now these numbers are estimates based off previous years, and we can't really know until we build the robots and test it.
Okay, any other questions from online or anything as well?
I've got a question, like, how does driver control work or manual control two robots?
Yes, so we would have two controllers, and we would there would be 3 or 4 people in mission control, so one person would take each controller and control each robot individually. Yeah, we're allowed to have as many as we need. We can even have multiple laptops to be able to completely separate it to make it more clear which one is which, but that will depend on what we actually need for that.
Question online says, assume latency / bandwidth of interbot communication is not a concern.
Yes, so what we found last year was that our running on 5 gigahertz Wi-Fi, we did not have any significant latency concerns. We also are able to run on 6 gigahertz with some of our components, so we will expect that there will not be significant latency concerns between the two robots. Additionally, it might just slow down the transfer, but each robot will internally deal with everything themselves as of now, so there is no need for it to be there's no need for a super real-time communication.
Yeah, and as mentioned previously, everything's on a handshake basis, so there is no way that physically these robots can approach each other in dangerous ways without the necessary communication, transfer and acceptance. Yes.
I think I had mentioned this to you guys a couple of weeks ago, but regarding the mini-bot path, once it's gotten that first path, can you use that previous path or that previous route to then almost breadcrumb, or not to go through as much processing and error, checking with the cameras to get back and forth?
Yeah.
It's gonna be about the same path.
Yeah, absolutely. That is actually something that we are very strongly considering as well, because the longer we run our mapping scheme, the more prone to error it could get with our disturbance of the train, right? So that is something that we are very strongly considering. Okay, is that about it for software then? All right, awesome. Thank you guys.
All right, home stretch. All right, systems, not too much to cover. We are going to be implementing something new. It's called, I believe it was introduced last year, but we didn't really get a chance to use it. It's called the DFX. It stands for Design for X. X can be anything, requirements, the manufacturing revisions, etc. Basically, it helps us and our chief engineer be able to track our plans for manufacturing and meeting all of our technical objectives. And how does it work? It's very similar to DFMEA's. We provide you guys a checklist template. You guys will fill it out for all your important parts. So for reference, for excavation, it'll be your buckets, their belt and chain testing and stuff like that. And so basically there's 5 categories for this checklist. There's a design for requirements, design for revision, design for manufacturing, design for assembly, integration and repair, and then design for testing and inspection. These will be due by CDR. I hope you guys do not procrastinate on them. And you guys will be able to do up for design for assembly, integration, and repair, because we won't be able to actually test them. And just as an example for the very first design for requirements, basically there'll be a question there being like, hey, have you considered this this part? Have you made sure that it fulfills our system requirements? Have you made sure it fulfills what our technical objectives are? And also requiring a justification for it in the notes. And that's about it. I'm actually going to put up real quick, just to roll it out. Zoom out. But yeah, basically, you guys will have to fill out, will have to check yourselves off, provide justification for why you checked it off and why you are fairly confident. And then Andrew, the chief engineer, will get to review it, add his own notes, and be like, and whether or not that part is confirmed or some issues need to be fixed. One of the most important parts for CDR is manufacturing, and so this part will be very critical in terms of being like, hey, you know how you're going to actually manufacture the part instead of being like, oh, we should 3D print it or we should cast it or whatever. And so this helps us like establish what we're actually going to do for that part. So hopefully that will help us track it. It'll help Andrew keep track of everything and hopefully make the actual, when it comes to actually manufacturing, should make it a lot easier and straightforward.
Moving into our engineering lifecycle, we are at PDR, which is our second major review gate during our development phase of our competition. The last one is CDR, which is going to come up on most likely the second Saturday back from break. In between those 2 days, mostly for leads, we have 2 budgets due, one December 1st and one January 1st, just to keep it on.
It was due at the start of CDR.
At the start of CDR.
Yeah, not very first, not very first.
Instead of January 1st, that budget's going to be due at the start of CDR. A little more about the logistics of CDR. Like I said, January 24th is the tentative date for that. We don't have a location just yet, but once we do, we'll inform you guys so you're aware of that. A little more about what CDR is. You're going to have your finalized designs and hopefully be done with your design to be ready to manufacture, disregarding minor changes that you'll make based off of feedback that you get at CDR. You're going to generally have an idea of your schedule for manufacturing, so you're ready to start on that right when you finalize your design. And on the next slide, this is a little more of a breakdown of the deliverables that each sub-team will have to prepare for CDR. You can see a more in-depth checklist in a drive within the review gates folder. There's a review trackers checklist. This is a spreadsheet that has everything that you need to know so you are prepared for CDR, because it is going to be coming up sooner than we expect with few amount of meetings due to breaks that we have. Major things that engineering sub-teams will need to have is that manufacturing schedule, any FEAs that they conduct are good to include in that. And also that DFX that we're implementing this year. Systems, we're gonna have those DFX checklists for you guys. We're gonna have an integration report. We're gonna have testing schedules and hopefully a ConOps share with you guys about the working with software on that to show the bigger picture of how the robot will be moving during competition. And then I'll hand it over to Hans for some concluding remarks.
Alrighty, what an exciting day. Upcoming deadlines and dates. December 1st will be budgets due for sub-team leads, so make sure to get those in. Other than that, we have no major team events besides team meetings before winter break, so that's nice. CDR will be January 24th, as mentioned. I believe we're looking at trying to get Forney G140, which is where we were in the morning again for that. After that, we have some NASA deliverables such as team photos and media releases. We'll handle those as the date gets closer. Same thing with the other system deliverables, which are mentioned on that slide. Other than that, I think this is a very productive PDR. I hope all the sub-teams got some valuable information and we will have a very successful CDR. So thank you for those who tuned in. Thank you for those who showed up in person. So we have several alumni here today. I appreciate you taking the time out of your busy lives to be here and give your feedback to the team. And thank you to those who tuned in online who are not part of our team. We really appreciate your input. With that, Purdue Lunabotics 2025 PDR is concluded. So thank you guys.